Before I begin, I wanted to thank TI for really understanding the fundamentals of open source software and not just the marketing material side of it. It allows me to do presentations like this everywhere. So thank you for them for having just an open source mind. Next, please don't get me in trouble by anything I say here. I'm really capable of getting myself into all sorts of trouble all by myself. But with that out of the way, let's go. So typically, when you start in designing an application or a solution, you're going to gather all your requirements, right? How fast things need to work, what you need to do with it, how to accomplish that requirement before you make any type of hardware selection. Some of those requirements, might have some type of deadline, right? A maximum response time, a latency that you have to do that work in before that deadline is reached. So you make the accurate prediction, like, okay, a real-time kernel was probably a good fit here. And so you go out and buy some reference boards and with SoCs that you think are capable of meeting those requirements and that are fast enough to finish the task in under that deadline. But I work for an SoC manufacturer, right? So wouldn't it be great if that reference board that you selected had a TI part on it? It's in my best interest. So it's in my best interest to make sure that our reference boards and our SoCs perform their best at a wide variety of use cases. But I don't know what your application is going to be, right? So I have to make sure that the real-time Linux kernel performs its best no matter what application it is. So for a quick refresher real quick, the real-time patch set, which I guess I can't call a patch set anymore now that it's been merged into the mainline kernel. I guess it's just a config change. The entire goal of the real-time Linux system is to maximize the time the CPUs stay in an interruptible or a preemptible state. This allows the scheduler to reschedule tasks at any point it deems necessary so that eventually, when a new task or a real-time task, a more important task, whatever, comes onto the system and wakes up, that CPU is automatically running that task as quickly as possible. Essentially, as Stephen likes to call it, we're making Linux a deterministic operating system, a DOS. But compared to a real-time like a free RTOS or a hard RTOS, it's not mathematically proven. Systems I call hard real-time are mathematically proven, but through enough testing, and we can be reasonably confident that real-time Linux will behave as expected. And any missed deadlines that we don't have that we don't meet in Linux are just bugs. So it's a perfect use case of when you don't need a mission-critical hard real-time system, but you still want those deadlines and those schedules to be met. However, all this work in the real-time kernel doesn't necessarily take latency out of our systems. We will always have some sort of latency. Using the real-time kernel can even, in some certain situations, increase the latencies that you see, though even though they're now bounded, they're still there. So what the maximum latency we'll see is essentially up to us, right? And how we configure the system to perform. However, that doesn't stop people from the first thing that they do is grab our reference board, boot a real-time kernel, and then bring out cyclic test or RTLA and put our SoCs in various situations to see how they're performing. So even though the real-time kernel has done quite a lot of work to ensure CPUs stay as preemptible, we still need to minimize that value so that we can ensure that your goals and your deadlines will be met even with the tightest duty cycles and deadlines that we have to meet. So how do we do that? Naturally, it means we do a lot of testing and experimentation, right? But this inevitably finds bugs in our software. One great example from a couple months back is we started doing an integration of a new long-term stable kernel, and then we very quickly, halfway through that integration or that porting, we started seeing a blip like you see. 50 to 100 microseconds, all of a sudden just 1 in a million samples would just be almost double what we were expecting. So after a little bit of like banging our heads against the desk and tracing and all sorts of things, we finally found out that it was a critical section in our random number generator, but it was in opti. So it was when our bootloaders changed and upgraded that we saw this regression. So it's not only the kernel that we have to be wary about, we have to worry about ATF, all kinds of binaries, opti, U-boot, setting something up, putting it in a configuration that we in Linux might not have control over. So it means we have to do a lot of testing and a lot of just binary searches through all this code. So to essentially recap, we have multiple binaries, ATF, opti, U-boot, any sorts of things, firmware is sitting on the accelerators with potential bugs. I mean, they all have bugs, but some of them are latency impacting bugs, something that we care about. So how do we methodically test all these SoCs for real-time Linux that could help us identify these issues before they get to our customers? And so if you look at our interrupt architecture, it's a little complicated just because of the way we partition heterogeneous SoCs. Some of them will be like a microcontroller domain, some will have an application control domain, some will have bigger, and it's complicated, but essentially there's 3 main ways we can interrupt a CPU on the system. The very easiest thing we can do is just run stressing tools. These tools like stressng and hackbench are ubiquitous on many distributions, and they provide a wide range of ways we can put the system into different states and measure its behavior. So the first kind of real test that we like to do is using some simple tests, stressng to put the CPU in a busy loop. And then we'll use RTLA to analyze what the system can do. So we have this background load like computing Fibonacci, and then we have RTLA running in a real-time thread so that we can measure how fast that context switch is. And that does a really good job of testing inner cluster CPU interrupts. Next, we can go into changing out that background load. So for example, we can use perf. Perf just, can we send a gigabit through the Ethernet controller and still run RTLA in a reasonable time frame? Is that going to stress the system? What are we going to see? Another great example is, well, this example takes an interrupt from outside of the compute cluster, routes it through our interrupt controllers, and then interrupts the CPU. So it's an external interrupt, but it's still inner SoC. And then finally, we can also use a completely external. So a GPIO-based interrupt. We have a GPIO pin configured as an input. We connect a wave generator to it. And then we mirror that with a kernel driver to another pin. So if the input pin goes high, that output pin will, as quickly as possible, try to go high. And then we can connect an oscilloscope to that. And that lag between what the wave generator does and what our mirrored pin is doing, we can take a persistence capture and measure the difference. And that minimum and maximum latency, it becomes the latency of how fast can we interrupt the CPU and configure that pin to mirror that state. Yeah. So with all these, I mean, those are 3, I mean, there's many more tests, but those are 3 types of categories that I tend to categorize all these tests as. But what did we find anything, and what kind of tips could we give to people when they receive their SoC to help them meet their expectations that they have? So before I start going down this road, like everything, or most things, everything is a balance. Every use case will be different, and prioritizing one thing only will degrade another. For example, maxing out a CPU's tick timer, so an inner cluster interrupt, for a use case that demands an external interrupt. Say you're trying an EtherCAT master, you're trying to respond to an Ethernet frame as fast as possible. Increasing your tick timer isn't going to do anything but increase the number of interrupts that the CPU is going to have to manage. So that's not how you're going to get your latency down. However, some things that we do find that help a lot is just disabling unused applications. Most of these distributions, and especially ours, will have a lot of demos and a lot of test frameworks running in the background, which is great for an out-of-box experience, but for a real-time application, that's just busy work for the CPU. So just disabling unused applications will help the IP in that system that's being shared to open up its bandwidth and allow more time for your applications to run and less interrupts to have to deal with. So improving your system latency. Next is the kernel size itself. If the page table on ARM64 based kernels is fairly gnarly. Minimizing the kernel does things like improve TLB walks. It minimizes the chances of having to take a slow path in the memory management subsystem. So the smaller the kernel you have, the less likely you will encounter these slow paths. And so you can improve the performance just simply by just eliminating drivers that you don't need. It also has the benefit of, so your A53s are clocked at 1.4 gigahertz. You have 1.4 billion instructions per second. The number of instructions, if you make the kernel smaller, that's fewer instructions that you will be spending on a kernel context, giving you more instructions that you can use in your application to user space. So not only does it help kernel sizing in the kernel itself, it also gives you more time in your duty cycle to run the application that you want. And then you can start, DDR will always be a bottleneck on embedded systems. You can buy bigger DDR controllers and bigger SoCs, but those cost money. So one simple way is just to mess with the AXI and, in our case, TI's CBAS priority. If you know that you won't be using an IP or that IP will be used only in a background load context, move that down in the priority mapping so that when that read or write request makes it to the controller, it's prioritized correctly. And then internally, we see great improvements with this, obviously. Before we started monitoring real-time tests, before we did any type of benchmarking, it was mostly just regression tests. Do we see that blip, kind of like the Opti blip? We were sitting comfortably at 120 microseconds context switch latency, worst case. And with these improvements and continuous integration cycles, we've gotten that nearly halved by 63 microseconds here on our AM62, which is by far one of our weakest DDR controllers. It's 16-bit data lane with 1600 mega transfers per second. So it is quite small, but 60 microseconds to context switch with that. I mean, you're moving page tables. So it's not too shabby. But like I said before, all of this optimization comes at a cost, right? These configurations will help us optimize for specific use cases, but it'll help us monitor for optimize for specific use cases specific to our SoCs, which means now our distributions, your distribution, our customers, system integrators will have to pick up this increased burden, right? Because every application will have a different configuration. this incentivizes the industry to quickly abandon support for solutions that no longer bring in revenue, right? Now it's just a cost, which it inevitably leaves these devices that we're making old and vulnerable because they don't receive updates anymore. I say this is an issue because with the real-time kernel merging with the mainline kernel now, more and more people will start looking at the real-time Linux kernel and finding ways to integrate that into their solution. So finding a way to decrease the burden of testing, configuring, optimizing each SoC for their applications, we need to find ways to automate that and do it ourselves, I guess, just to increase the security and longevity of ARM SoCs in the industry as a whole for real-time Linux. So, anywho, thank you so much for attending this talk. If you have any questions, please feel free to reach out or raise your hand. A few of us are always available on IRC if that's your preferred way of communicating. But thank you guys so much. Have a good day.
And thank you so much, Brian, for that presentation. It was really interesting to hear about all these different strategies that are available for optimizing. I know that's a big word these days, and everybody's trying to optimize systems and processes. That's really interesting to learn more about how that can take shape. And I see that we have some questions coming in, and I just want to remind the audience one more time that those are available over on the right-hand side of your screen. If you have any questions that you'd like to submit, we'll be able to address those questions. And so Brian and Pekka, are you guys ready for some of these questions?
Yeah, let's do it.
Perfect. So our first question says, how does real-time Linux compare to RTOS in terms of things like latency and what does that mean for embedded processing?
Yeah, that's a good one. So real-time Linux is never designed to replace like a hard RTOS. So think of like medical devices or anything like that. You cannot miss a deadline. Real-time Linux is trying to fit a middle ground there, right? So you still want all your applications to run. You want that standard networking stack to work, but you want to handle some use cases at a certain period in time. So it's mostly just a mindset change in there.
But maybe Brian, let me just try to maybe add some numbers to it. Is like what Brian was showing is kind of real on existing like embedded processors, $5-10 range. So deep embedded processors, you can get Linux to, let's say, 50 microseconds. So it's all about the guarantee of the worst case. Average is down at, let's say, 5 microseconds. The worst case will be at, let's say, 50. So embedded Linux, 50 microseconds, you're in the world of realistic numbers. RTOS, you can get to 10 microsecond or even single digit microsecond level guarantees. Again, on a gigahertz processor, 1 microsecond, 1,000 instructions. So that's not, you can't do too much there. But RTOS, you can do something. And then if you need to go below that, then you're in the FPGA world or in the TI portfolio. That's what we call PRU cores. So there are microcontroller cores that sit next to a GPIO pin. Then you're in the, let's say, 10 nanoseconds type guarantees. But and below that, you got to use hardware gates and so on.
All right, and our next question is talking about heterogeneous architectures. It says, particularly with shared resources like CPU and memory, what strategies can help manage performance impact of those heterogeneous architectures?
Okay, so maybe I'll start on that one. So yeah, so as Brian brought it up, it's a balance that what is the priority of the application. So sometimes networking might be the king. So you want the real-time performance for your Ethernet traffic. Sometimes it might be, I don't know, the display. You don't want a glitch on your display. You can easily imagine that in some control application, you want the control to work, so network traffic runs. If the display glitches once in 1,000 hours, who cares? But you might not want the command that's going out to the robot arm to glitch. You'd rather have the screen glitch. So you make the trade-off. The user, so the platform gives you the tools, but the application needs to know what it wants to prioritize. It's like an ambulance in traffic, right? It's the ambulance gets the priority, everybody else stops. So it's not like everybody wins. It's somebody wins and everybody else loses type of situation. You know. And then, so coming back specific to the question, what we tend to say is, as Brian pointed out, the DDR, so external memory interface, that's the typical bottleneck. That's why we put significant amounts of onboard SRAM on these devices. So your MCU core, partition it out, use just internal memory. Now you have deterministic guarantees in the microsecond range. Once you go out to the DDR, you have a bunch of cores sharing. No matter what you do with the priorities, you're like an order of magnitude more disturbances just because you're sharing a narrow pipe across a bunch of places. So truly partition internal memory, that's the hard real-time guarantee. Any shared resource is going to be a compromise.
Well, our next question is not talking about shared resources, but somewhat related. This question says that there are a number of background tasks and different workloads happening. Do you have examples of how TI can tune the SoCs for the performance? In so that's talking about when there's various background tasks and workloads.
Yeah, so we definitely have a lot of demos. I guess they're going for use cases. I know Pekka has been working on a few demos for a couple shows. But yeah, hard numbers, I don't think we actually publish anything like that. We should probably do that.
Yeah, fair. So we've done like EtherCAT, which is this like an industrial control protocol, low level, completely latency driven. It's used to control robot arms, like in the machine that builds the machine. Usually that's usually the systems are such that the controller is perhaps running Linux, then the devices it's controlling are microcontrollers running bare metal or RTOS, but you still need some guarantees at the controller. And we've done some work on that to ensure that application gets to run every millisecond, every 500 microseconds. And once you get down to like a 100 microsecond range, that's going to be the limit of Linux. So and the specific tools underneath is like Brian briefly showed, we have some quality of service capabilities, which really make a difference once you get to the DDR, because there's a bunch of people trying to use the DDR, so the external memory, who gets priority. That's what you want to do. You probably don't want to like have, we support 8 priorities, ARM standard has 8 priorities. That's kind of too much. You probably you need to know what's your real-time thing and keep that above everybody else. If you're trying to do multiple levels, your complexities quickly blow up. So the quality of service, and then we do have on some of we have these what we call bandwidth limiters. So we can create at the initiator, the point which is generating the traffic. So you can easily imagine, let's say a GPU, a graphics processing unit, is creating a lot of traffic. We can put we have bandwidth limiters there that kind of throttle it at the source instead of trying to do quality of service at the destination. So if you can throttle at the source, it's better. But you can't. Yeah, right. You really want to throttle the big boys, or the ones creating a lot of the traffic. So that's why the bandwidth limiters are only in some places, not across everything.
And you mentioned quality of service here. This next question actually kind of refers back to that again. It says, how does QoS or quality of service play into the reliability performance, especially when you're dealing with concurrent and background processes for real-time Linux?
Yeah, it's a pretty broad question. Let me kind of take it from the broad to go specific to maybe to Linux, but I always like to go back to this kind of a traffic analogy. At least most people are kind of familiar with the quality of service from like a traffic situation, that up to a point everything kind of flows smoothly. That's your average situation. Then you have something special happened. There's a disturbance, and it kind of all falls apart. So like a perfect quality of service would be something that you perfectly interleave everyone there. Then somebody breaks a little bit harder, the whole thing collapses. So that's those. It's exactly the same. What you're trying to do is you're scheduling things over time across a shared resource, and yeah, and that's where the same kind of algorithms and principles apply, but generally you do want to make sure you understand what is the thing you're trying to prioritize. And if you prioritize everything, you're prioritizing nothing, right? The value of quality of service is the fewer things you prioritize, then you actually make a difference, because it's all a relative game, and kind of a sadly a zero sum, or even worse, that you create priority by pushing everyone else down. And that's the nuance. The key is figuring out what is your priority, and then giving it the bandwidth and throttling everybody else down.
Our next question is an interesting one. I'm going to ask about TI specific, device specific features, and how do those address some of the challenges in embedded systems for real-time Linux?
Yeah. So, I know our PRUs, like each time I go and talk to customers, it's always our PRUs are pretty popular. I think what another really cool thing about TI is, as primarily a software engineer, I get to sit really close to the hardware people. And so we get to do really cool things, like just during layout, we can move the DDR controller closer to the application cores, or to closer to we can modify that layout to fit our workloads, which I think just makes us a little bit more unique in the industry. Just being able to work closely with hardware, and hardware working closely with software, we can actually just make sure that these performance improvements are make it into the design. It's not an afterthought. It's literally baked into the SoCs.
Yeah. Maybe this is the kind of an addition there, that that's the I come back to that. Let's say at the we ensure there's kind of a levels of real-timeliness. There's PRU cores, which are controllable from Linux. So you would offload if this hardware signal comes in and I need to toggle this other pin based on that signal in a deterministic manner, that's perfect fit for PRU core. That's like a remote processor from a Linux perspective, and its real value add is the general purpose IO pins show up as registers in the core. So it's the maximal latency, the best latency you can imagine for software. Now, and then we have the MCU cores for like another 10 to 100 times less real time, but still in the microsecond range. You can control things, and then for the actual RT preempt RT Linux with the empirical guarantees, which in the big scheme of things, everything is testable, right? It's not mathematics that runs on the silicon; it's physics. So there is always some level of uncertainty. It's just that what is the uncertainty? So I wouldn't, like what Brian was saying overall on the Linux side. It's empirical, but if you really zoom in, so is everything. So.
Well, I just want to remind the audience one more time that if you have any further questions, you can submit those. We still have a few minutes left. So Brian and Pekka, do you have any key takeaways from this session? Any final thoughts or points that you want to highlight for the audience today to give them just a couple more minutes to submit any more questions that they might have?
But I don't know, Brian, the latest news on the, I know because the latest news on the preempt RT making merging with the kernel. Any comments on that?
Yeah, I mean that was a long time coming. I'm excited to have worked a little bit on that help, but it for me it just signals that the work has just begun.
Can you kind of summarize it for those of us who might be super familiar?
Yeah, so for I guess the last 20 some odd years, all of these patches that we've made to make Linux deterministic has been out of tree. Essentially, it was another fork of the project that was following closely behind, but was slowly trying to implement things or slowly trying to get all of that stuff working. How the locking subsystems operate, how those changed, all the mechanisms in the core fundamental parts of the kernel were changed and updated. Now, one of the last holdouts was the print K. Essentially, what happens is the lines printing to your console, the CPU that's doing that can't be interrupted until that line is done. So that whole time that line is being printed, the core is non-preemptible. And so a lot of that work is finding a way to allow that to be preemptible. It finally was accepted by Linus with a golden bow. And so essentially all of the work that we've done is now in the Linux kernel, and it's already seeing improvements, like the tracing subsystem, the locking mutexes, spin locks, all of that has really benefited from the Linux kernel. But yeah, the fact that it's merged just means the work is really just starting.
Is it? I just have to ask. Is it just a rumor, or was it true that the actual last piece of code was literally written by Linus?
It was, himself? Yeah. Thomas.
That was patched.
Yeah,
so his code was the last offender.
Yeah. Thomas sent it over. Yeah, it was him.
Well, once again, gentlemen, thank you so much. Thank you, Brian, for the presentation, and to both of you, Brian and Pekka, for the insight and the additional information during our Q&A session. I know I learned quite a bit about this, and I'm sure the audience did as well. So thank you so much for both of you for joining us today. We really appreciate it.
Yeah, thank you for having us.
Thank you.
And before we wrap up with the session, I would also like to announce the prize winners for this session. So congratulations to Jonathan Williams and Ray Miller. We'll be in touch with both of you within the next week to make sure that we have the info that we need to send you those giveaway packages. And to the rest of our audience, thank you so much for attending Industry Tech Days 2024. And a special thanks to our event and giveaway sponsor, DigiKey. And thanks to our event partner, Electronica. If you happen to be in Germany, November 12th through 15th, definitely check out their in-person trade show in Munich. And in just a moment, you'll be redirected to Texas Instruments exhibitor booth. And I encourage you to check out the other live sessions, keynotes, published content that are happening today and the rest of the week for Industry Tech Days. And on behalf of all of us, thank you so much.
Hello, everyone. Thank you for joining us on day 3 of Industry Tech Days 2024. I'm Dale Wilson, Director of Engineering and Content at All About Circuits, and I'm back again to moderate this next session, which is titled Creating Safe and Reliable Battery Management Systems. Let me tell you about our presenters. Terry Yao currently covers product marketing for ST Microelectronics' Smart Power Solutions product portfolio, which encompasses a wide array of automotive ASIC products. Her experience in the semiconductor industry includes the design and product development of wireless transceivers and automotive radar. George Slama is a senior application and content engineer at Worth Electronic, working on application notes, seminars, and software tools to help engineers use magnetics effectively. His experience includes designing all types of transformers under 10 kilowatts, quality control, manufacturing engineering, automated testing, and power supply design. Following the presentation, we'll have a live Q&A with Terry and George. You can submit your questions at any time during the session using the chat box on the right-hand side of your screen. Thank you so much for joining us. And with that, I'll hand it off to Terry and George for the presentation.
Hi, everyone, and welcome to today's webinar focusing on the topic of BMS, or Battery Management Systems, and highlighting the L99CC3E, a 14-cell lithium-ion battery management IC from ST Microelectronics. My name is Terry Yao. I work in product marketing in the Automotive Products Group at ST, specifically supporting the SPS, or Smart Power Solutions Products Division, and I am based out of ST's Livonia, Michigan office. Here is the agenda for today's webinar. We'll start by looking at the main objectives for battery management systems, followed by the key enabling functions from the BMS IC. Then we will dive into the L99CC3E, looking at its many features and architecture, along with the companion transceiver device, the L99CC3T. Finally, we'll conclude this webinar with a look at all the collateral offerings for this BMS family, as well as potential applications. Let's start by taking a look at the main objectives for battery management systems. First and foremost, in any battery-operated device, safety is a top concern. We want to maintain the battery pack in a safe operating condition to prevent fires and other disasters, and thus need to monitor for any faults that may occur. This involves accurate measurements of the cell voltage, current, and temperature, along with isolation detection measurements and redundancy measures. Once the safety aspect is covered, we then want to maximize the performance and efficiency of the system. To maintain high levels of performance, we need a way to accurately assess the level of charge in the battery. And we also want to optimize the efficiency to extract the maximum value out of the battery pack. All of this is dependent on the accuracy of the cell measurements. Finally, we want to extend the service life of the battery pack to as long as possible. And to that end, we need to prevent any operating conditions that may shorten the battery life. This requires accurate and reliable cell balancing, as well as effective thermal management in the BMS. This slide illustrates in detail how the BMS objectives are met with a monitoring IC. The 4 key BMS functions that help us achieve these objectives include cell voltage measurement, current measurement, cell balancing, and thermal monitoring. For cell voltage measurement, accuracy is critical for determining the state of charge. This helps prevent any overcharge or over-discharge in the battery pack. Likewise, current measurements also need to be highly accurate, and this is linked to the fuel gauge function as well as protection against short circuit conditions. Cell balancing is critical for maximizing the battery capacity and service lifetime, and finally, thermal monitoring contributes to safety of operation as well as service lifetime. Now let's take a detailed look at the L99CC3E and see how its features and operation address the key BMS objectives we talked about. The L99CC3E is a 14-cell lithium-ion BMS IC from ST. The device can manage anywhere from 4 to up to 14 cells connected in series. There's also the option to daisy chain up to 31 of these devices. So depending on the cell chemistry in use, that will give you a battery pack voltage in excess of 1500 volts. This device can manage both low voltage battery packs as well as high voltage battery packs. Cell voltage and current measurements are supported by this device. You can see in the diagram here, the cells are connected on the left. The balancing FETs are internal. Balancing current is supported up to 200 milliamps per channel. You can connect an external resistor to limit the current during balancing. The cell measurement ADCs are integrated as well. A unique and beneficial feature of this device is that there is not a single ADC, but rather 14 ADCs with one dedicated to each cell input. The important benefit of having the dedicated ADCs is that we can make highly synchronized, high-precision cell measurements. It's very accurate in that when you issue a command to sample the cells, you can sample all the cells simultaneously. You can also measure the current at the same time that the voltage is measured. And if you have a high voltage battery pack with multiple devices connected in daisy chain, the only desynchronization from the lowest cell measurement to the highest cell measurement is the time that it takes for the measurement to propagate up the daisy chain. In the example of an 800 volt battery pack, that propagation time is on the order of 2 microseconds. Current measurements are made with continuous time sigma delta ADCs. There's a wide range in filtering time that can be applied to the converters. And the main advantage of this is that the converted value represents the average value over the sampling window. So any noise present on the signal will be averaged out and filtered. The longer sampling window you can tolerate, the more noise attenuation you can achieve in your measurement. This is another differentiating feature with our solution. Another highlight of our device is its accuracy performance. Recall that measurement accuracy is a critical parameter in BMS modules due to its impact on virtually all aspects of battery management. For measurement accuracy, we specify plus or minus 1 millivolt initial accuracy with a maximum accuracy specification of plus or minus 1.4 millivolts when accounting for the effects of drift due to soldering or aging. The accuracies are specified over the entire operating temperature range of the device and vary according to the cell chemistry in use. There's a slide later in the presentation which details the measurement accuracies to be expected based on the usage case. Current sensing with Coulomb counter is integrated as well. This is done through an 18-bit sigma delta converter with 17 bits plus sign for both positive and negative current measurements. There's a 0.5% error on the current sense amplifier circuitry. Hence, you can make highly accurate current measurements on this device as well. In terms of communication interface, there are 2 communication interfaces built in. There is a standard 4-wire SPI interface at 6 megabits per second. So in the case of a 48 volt battery pack, without the need for multiple devices connected in daisy chain, the typical architecture would have the MCU being connected directly to this 4-wire SPI port without any need for isolation. In the case of high voltage battery packs, there is the need to be isolated from the chassis ground domain. So for that, we have the isolated communication interface shown here, with the ISO H being the high port and the ISO L being the low port in the system. Both mono and bidirectional daisy chain configuration are supported in this device. In terms of the bidirectional daisy chain, you can also have a dual ring configuration. And this basically enables you to communicate from the bottom of the stack upwards or the top of the stack downwards, so that in the case of a fault anywhere in the chain, you can still communicate with the device. And this concept is illustrated in more detail in one of the slides later in the presentation as well. For cell balancing, you can balance all 14 cells at the same time, maybe not using as high a current as the 200 milliamp maximum balancing current per cell when balancing simultaneously, and this is mostly due to thermal limitations. For balancing, there is both a manual mode as well as a timed mode. to perform the balancing. External balancing is also supported if higher balancing current is needed. There are 9 GPIOs present on this device. Some of these can be used for NTC monitoring or temperature monitoring. In addition, there are also 14 bytes of user-accessible NVM integrated in the device. And finally, because this device was initially designed with an automotive application in mind, it is AEC-Q qualified per automotive standards, and it is also compliant with the highest level of functional safety, which is ASIL-D, which is typically required in safety critical applications, such as in EV applications. Focusing more on the architectural benefits of our implementation, by having dedicated ADCs, desynchronization is definitely a key benefit. The 14 cells are measured at exactly the same time. Less than 2 microseconds desynchronization time can be expected in an 800-volt battery pack. Safety is another key benefit. Having dedicated ADCs per cell leads to a fully redundant conversion path via the adjacent sigma delta ADC for each cell. In case of ADC failure in any cell, that cell can then be converted by an adjacent sigma delta ADC. The slide illustrates in more detail the difference in desynchronization between our implementation and that which does not have dedicated ADCs per cell. With the dedicated ADCs, all voltage and current measurements can be taken simultaneously, resulting in a significant reduction in the total conversion time. This approach also greatly improves the accuracy of the readings by providing a single snapshot in time of the voltage and current readings in the battery pack, thus eliminating any inaccuracies resulting from the delay from the first measure cell to the last measure cell. With the dedicated ADCs, we're able to tolerate a longer conversion time per cell, resulting in BOM cost savings for external passive filtering components. Additionally, the continuous time sigma delta converters also have 8 programmable filter options, with a longer filtering time leading to better noise attenuation. Here is a more detailed look at the cell measurement architecture. The cells are configured in pairs, cell N and cell M plus 1. Connected to ADC-N and ADC-M plus 1. We have the capability to cross-check these two ADCs against each other, and they're also connected to independent voltage references that can also be checked against each other. So if there's ever a fault detected on one or the other of these measurement paths, the faulted channel can be swapped and measured on the good channel. If you have a fault on the channel N plus 1, cell M plus 1 can then be measured by ADC-N. You've lost your synchronization capability now because you're no longer able to make those measurements at the same time, but at the least you can still see what's happening with the cell that's connected to the faulty channel. So that's definitely another important benefit of this architecture from a safety and redundancy perspective. Another unique and beneficial feature of this device is its accuracy performance. Shown here in more detail for different operating conditions and cell chemistries. Here you see a range that's typically representative of an LFP chemistry, up to 3.2 volts. Initial conversion accuracy is specified to be in the plus or minus 1 millivolt range over the entire operating temperature range. Additionally, we have characterized the accuracy also taking into account the effects of drift, whether due to aging or soldering, and the 1 millivolts becomes 1.4 millivolts at the end of the life of this device. This accuracy performance is among the best solutions on the market. This is the L99CC3T device, which is part of the L99CC3 family of BMS offerings. The T here standing for transceiver. So this is a general purpose SPI to isolated SPI transceiver and serves the function of creating a communication bridge between the devices located on different voltage domains. Using a high voltage battery pack, such as in an EV application as an example, the L99CC3T is used as the communication interface between the chassis ground domain and the high voltage ground domain. This device supports both transformer and capacitive isolation, and is also compatible with 3.3 volt and 5 volt logic. Note that the same isolated SPI interface is also built into the L99CC3E device. Here's an application example with the L99CC3E and T devices. Here, multiple BMS ICs are daisy-chained to monitor a high-voltage battery pack. The devices are connected in a dual ring configuration, which allows for a higher level of communication integrity, where recovery can be guaranteed in the event of a single open failure in the communication wires. The L99CC3E device supports bidirectional dual ring daisy chain configuration so that you can communicate from the bottom of the stack upwards or from the top of the stack downwards, such that in the case of a fault anywhere in the chain, you can still communicate with the device. This configuration consists of 2 SPI peripherals on the MCU, as well as 2 L99CC3T transceivers on the master PCB. A number of development boards and kits are now available for evaluation of the L99CC3 BMS family, including the device eval board, an MCU discovery board, a battery holder kit, and a SPI to ISO-SPI dongle for communication between the MCU and the BMS IC in the different voltage domains. Additionally, all supporting documentation, including the datasheet, application notes, safety manual, etc., are also available either for download online or provided on request. Since batteries are everywhere around us, there exists a wide range of target applications for BMS ICs. In the automotive space, the introduction of EVs have led to a significant focus on BMS modules, and there are also a large number of industrial applications, including energy storage, power tools, line equipment, just to name a few. The type of BMS IC employed for these different applications depends on the specific system requirements, such as pack voltage level, cell configuration, cell chemistry, accuracy specifications, etc. And within ST's BMS product portfolio are offerings that address many of these applications in both the automotive and industrial sectors. And that concludes the presentation portion of this webinar on BMS ICs. I hope you found it helpful and informative. Additional information on our BMS product offerings, along with data briefs, data sheets, application notes, and other collaterals, can be found on our website at st.com. Thank you.
Welcome to this part of the webinar where we will talk about the transformers that Worth Electronic has for battery management systems. My name is George Slama. I'm a senior application and content engineer based in Watertown, South Dakota. You may be wondering what transformers have to do with managing batteries, but as we heard earlier, it's very important to manage batteries at the cell level of 3.3 volts, even though the complete pack may be at 400 volts, 800 volts, or a higher voltage. The battery management ICs all operate at lower voltages and are usually ground referenced to the module that they monitor, yet they must be able to communicate with other modules and the master controller, which all have different ground references. For this to happen efficiently, the battery modules must be able to communicate without a ground reference. A battery module consists of a group of individual cells, and each cell needs to be monitored. The L9963E can monitor up to 14 cells. Using a system that's not ground potential based, but rather differential signal based makes it easy. The system that has been developed uses a serial bus with differential signaling between the modules and the controller in a daisy chain fashion, which can also be connected in a complete loop for redundancy. The signaling is based on the serial peripheral interface, SPI, which is one of the most widely used interfaces between microcontrollers and peripheral ICs. However, SPI is ground-based and uses at least 3 wires, but usually 4. Therefore, a transceiver circuit was created to convert the single-ended data lines into a differential signal using twisted pairs of wires. This transceiver can be a separate IC, or it can be integrated with the BMS IC. The ISO SPI interface uses differential signaling on a balanced pair of wires, where neither wire is grounded. With this configuration, the common mode noise impressed onto the wires by external EMI noise is nearly identical on both wires, and the transmitted differential mode signals remain unaffected. The recommended ISO BI interface uses transformers to magnetically couple and electrically isolate the signal between the devices. This shields each device from common mode voltage swings created by the system noise while transmitting the information across the dielectric barrier, which bridges the different ground potentials. This is the same technique used in twisted pair Ethernet. Furthermore, the electrical isolation allows the battery modules and packs to be interconnected despite the large DC voltage differences between them. A transformer is used to bridge the isolation barrier, but it must be selected for the appropriate DC standoff voltage for the voltage of the battery pack. A transformer offers excellent isolation and high immunity to bulk injection currents and to common mode noise. The transformer does have some specific design challenges. The signal portions requirements are straightforward in that they're similar to those of an Ethernet transformer with regards to inductance, insertion loss, and frequency response. However, the challenge is the isolation needed to meet the creepage and clearance for safety at high voltages in the battery pack. Normally, communication transformers fall under IEC 62638-1, but that standard only applies to systems up to 600 volts. Additional standards like IEC 60664-1 then apply. Furthermore, there are specific vehicle standards for high voltage that must also apply. In all cases, the creepage and clearance distances can be much greater than a typical signal transformer. The usual result is a larger transformer size, sometimes just so that the terminals are far enough apart. The WE-BMS transformers come with up to 15 millimeters of creepage and clearance, as I will show you in a moment. In order to have a long life, the transformer must be carefully designed not to have partial discharge. A particular problem with devices that operate at high voltage potentials is partial discharge. Partial discharges are localized dielectric breakdowns that are often caused by voids in solid insulation. When a high voltage is applied across an insulation, the charge will distribute across the barrier according to the dielectric constant of the material or materials. If the material is solid and homogeneous, the distribution will be even. But if there's a void or an air pocket, the charge will distribution will be uneven and will concentrate in the void because the dielectric constant is considerably lower in that spot. This will lead to a breakdown in the void, resulting in carbonization and an expansion of the void over time. This is partial discharge, which is not a complete breakdown, hence it's only partial. Eventually, it will lead to failure of the insulation over a long period of time. To ensure the long-term reliability of the insulation system, Worth Electronics carries out a partial discharge test in accordance with IEC 60664-1. The test involves applying a predetermined voltage at a higher level than working voltage for a short period of time, typically 5 seconds, and then reducing it to the working voltage plus some margin for about 15 seconds to get a measurement. The test voltage is determined by the insulation class, whether it's basic, supplementary, or reinforced. The test passes if the coulomb count is below a limit value of 10 picocoulombs. In the bottom right is the definition for creepage and clearance. The creepage, in red, is the shortest distance between two conductive parts measured along an insulating surface. Any irregularities in the surface, like a gap, must be a minimum size depending on the material class to count as part of the path. Clearance, in green, is the shortest distance between two conductive parts through air. The main difference between WE-BMS transformers and other parts is that we can meet the creepage and clearance distances requirements through physical distance. The physical distance requirements are met through an innovative housing design that forces and guarantees the distance, yet does not significantly increase the size of the device. You can see in the cross-section where the wire weaves through a maze. A subtlety is that this maze must have specific dimensions to meet the standards. The WE BMS transformers offer the highest physical creepage distance, increasing the safety and reliability of the system despite the small footprint. Every transformer module comes with an integrated common mode choke designed to match the application and increase common mode rejection. This means one less component to handle. It reduces board space and increases the reliability with fewer connections. The Worth Electronic product portfolio offers transformers with and without a center tap. In addition to the integrated common mode choke in the transformer module, the center tap contributes to suppression of common mode interference. For this purpose, a bypass capacitor is connected to the center pin, which provides a low impedance path to the ground for common mode interference and thus diverts it from the IC. This leads to an improvement in the ISO SPI performance. Here's an example of the styles of transformers offered. Many are available as 2 transformer and common mode chokes in one package, simply because, as you saw earlier, there is one communication pair coming into the BMS IC and there's one pair leaving it. Combining everything into one package simplifies the purchasing, handling, and assembly. There are also individual transformers offered for other types of applications. The WE BMS transformers are fully tested up to 6400 volts DC with working voltages up to 1500 volts DC, making them ready for the next generation of high voltage battery packs. They use high quality, fully insulated magnet wire to meet the reinforced insulation requirements in a reduced volume of space, and they are fully tested for dielectric strength and partial discharge. Here's an example of a screen capture from a partial discharge test. The purple area at the bottom is the coulomb count, which is well below the 10 picocoulomb line seen in the center of the screen. The chart on the left shows that the dielectric test is performed first at a high voltage level for a short period of time, and then the voltage is reduced to measure if there's any partial discharge. Here are a few layout guidelines. As always, keep traces as short as possible to reduce the noise pickup because they act as antennas. Place the transformer as close as possible to the connector, ideally within 2 centimeters. The IC also should be close to the transformer within 1 or 2 centimeters. Although not shown here, there will of course be some ESD devices and some EMI capacitors between the IC and the transformer, and between the transformer and the connector. With multiple layer PCBs, there must be enough clearance between the transformer, the connector, and other traces and the ground planes, at least 4 millimeters, but perhaps more depending on the working voltage and any applicable standards. Here are the common electrical properties. Just remember that the transformer and common mode choke cannot be separated, so the values apply to the combination of the 2 devices. If the turns ratio is not mentioned, it's 1:1. Pin 1 is marked by a dot, and the numbering is counterclockwise, just like an IC. In summary, the new WE BMS series contains a transformer to isolate the signals and a common mode choke in order to help filter common mode noise. The design from Worth Electronic provides a much higher physical creepage distance than other offerings and in a small package size with many low-profile options. Dual transformer design helps to further reduce component count and handling, and all the parts support the ISO SPI interface, such as used in BMS systems, and they're all fully AEC 200 qualified for automotive applications. That concludes my presentation. I return to the moderator, and then we can take any questions that you might have at this time.
Hey, thanks, Terry, for the handoff, and thanks, or George, and thanks, Terry, for your presentation as well. So we already have several interesting questions, but I want to let our audience know that there's still time to submit those questions. Use that chat box on the right-hand side. Terry, George, you ready to answer some of these questions?
Yes.
Ready.
Awesome. All right. The first one is asking, and I think this was directed for Terry, is what is the cell measurement range on the L9963E device?
Yeah, so cell measurement range is in the range of 0.1 volts to 5 volts. So basically the device measures positive voltages up to 5 volts. So one thing to note is we do have a new family of BMS devices that are starting production very soon, actually, the L9965 family. So in that family, there is the option to measure negative voltages as well. But for the 9963E, only positive voltages and up to 5 volts.
Okay. Our next question is, in the ISO lines with the transformer, how does the chip select and clock pass through as the transformer only has two ends, two lines?
I try to answer that question. I mean, basically, that's the function of the transceiver. So it's converting those single-ended 4 lines into differential signalings. So that's a part of the protocol that would go across that data set, just like an Ethernet application. I mean, I'm not an expert on that transceiver, but basically that's what the transceiver does. It takes those 4 single-ended ones, converts it into a type of protocol that can be transmitted differentially through the transformer.
Okay. Let's see. Next one. What software development tools are available with the L9963E?
Okay, so basically, if you go on our website at st.com and look up the L9963E, you'll find a suite of collaterals and software development tools. As shown in the presentation, there are a number of eval boards that are currently available. We have a new suite that's coming out that's part of our Auto Dev Kit family of development tools. So part of that tool, basically, you will have software, GUIs that you can use, which can basically help the user get up to speed very quickly in using the device, communicating with the device, and making some measurements with the device. And there are also, in these software tools, basically capability for the end user to script their own routines, basically to do some analysis with the BMS. So definitely GUIs and software communication tools are available, and information can be found on our website.
Okay, very good. Our next question is asking about you, and I think this would be George. You mentioned using fully insulated wire. How is it different from triple insulated wire?
Yeah, there's 2 types of wires that can be used to achieve reinforced insulation, and typically what's been used for many years is what's called triple insulated wire, which is a magnet wire that has 1 to 3 coatings of Teflon, separate coatings of Teflon over it, so it tends to be quite large. Fully insulated wire is enameled wire that has many coatings, more than the normal enamel wire. And it's been developed in the last 5 or 6 years, and now is fully approved. So the net result is that the fully insulated enamel wire is easier to handle. It's a little bit smaller, and we can solder it directly, whereas triple insulated wire, being made of Teflon, has to actually be mechanically have the insulation mechanically removed, and it's more expensive. So they both do the same function, but fully insulated wire is more manufacturable and lower cost.
Excellent. So the new fully insulated is fully approved.
Yes.
All right. This one is, I don't completely understand how the creepage and clearance are met.
Yeah, creepage and clearance, as indicated in my slides, creepage being breakdown along a surface and clearance being breakdown through air. So we meet it by there are requirements according to the standards. So at a minimum, you have to have the secondary and primary terminals far enough apart, and then you have to insulate the windings from each other. So we have that woven pattern where instead of having a long distance, we kind of weave it in between those notches in the housing, and that because those notches are a specific minimum thickness, we can count that as distance, and then we actually achieve a long distance in a short space.
Okay, that's helpful. Thank you. What's the difference between partial discharge and corona?
The two names are used interchangeably. Corona is usually associated with a glow, an ionization of the air because of high voltage, and you see it as a glow. Partial discharge is really the same thing, but usually it's inside in a void. So you have a sort of a solid insulation between two potentials. If you have a void in there, there's a different dielectric constant, and the charge will concentrate there, and you have a breakdown. You have corona in there, you just can't see it. So we call that a partial discharge.
Okay, thank you. Here's one back for Terry, another one on the L9963E. Do you have a recommended MCU to use with that part?
Yeah, so we don't typically recommend, there isn't a single MCU that is recommended as a companion MCU or anything for the 9963E. Typically, that would depend a lot on the customer's application. And basically for the BMS, some of the considerations would be, does the MCU, is it compatible with the communication interface, which in the case of the 9963E, it would be the SPI interface. And then does the MCU have the capability to support the number of GPIOs on the device, which in the case of 63E, there are 9 GPIOs. And so those are kind of just the preliminary considerations. Otherwise, it's really quite application dependent. And we have had customers who've used the device in both automotive applications as well as industrial applications. So, and then within the automotive application domain, really depends on any functional safety requirements and just whatever else is required in the system that might dictate, the specific MCU parameters. But basically, the device is flexible, can work with really any MCU. So just kind of keeping in mind some of these, the GPIOs, the communication interface, as some of the main considerations.
Okay, thanks. Well, it looks like we've answered all the audience questions. Thank you again, Terry and George, for your presentations and sticking around for the Q&A.
Hey, you're welcome.
Great, thank you.
Thank you.
And before we wrap up, I'd like to announce our prize winners for this session. Congratulations to the Daves, Dave Reuter and Dave Bursky. We'll be in touch with you within the next week to ensure we have the information we need to send you the giveaway packages. And we'd like to thank our friends at DigiKey for sponsoring Industry Tech Days and this giveaway. And thank you to our event partner, Electronica. We hope you join All About Circuits and EE Tech Group in Munich from November 12th to 15th at Electronica's in-person trade show. In a moment, you'll be redirected to ST Microelectronics exhibitor booth. Thank you for attending Industry Tech Days 2024. I encourage you to check out today's other live sessions, this week's keynotes, and the published content in those exhibitor booths.
All right, 5 minutes, guys.
We do start with camera on.
Just me, I think. You don't need to during the introduction.
That's right. Just Jeff. At the top of the hour here, when we go live, you need to have your camera and microphone off.
Okay.
Okay.
Good.
How are you doing? Are you good with the questions in that order, Mina?
Yeah, that order's fine.
Okay. Okay. Good.
Okay. One minute.
Okay, I'm standing by.
Perfect.
Hello, everyone. Thank you for joining us for Industry Tech Days 2024. I'm Jeff Child, Editor-in-Chief on All About Circuits, and I'll be your moderator for this next session. This session is titled Driving Industry 4.0 and Edge AI Innovation with the new STM32MP25X MPU. Let me tell you a little bit about our presenter. Mina Rumbakis is a product marketing engineer at ST Microelectronics with a focus on MPU products and security. Mina brings to the table over 20 years of experience in design, support, and marketing. His broad expertise covers various products, including microcontrollers, DSPs, and processors. After this presentation, we'll have a live Q&A with Mina. You can submit your questions at any time during the session using the chat box that you see on the upper right-hand side of your screen. So thank you everyone for joining. And with that, I'll hand it off to Mina for the presentation.
Welcome, everyone, and thank you for joining our Tech Day session. My name is Mina Rumbakis, and I'm a product marketing engineer with ST focusing on our MPU products. Today, we would like to introduce you to the newest MPU product family from ST, the STM32 MP2 series. Here you can see the STM32 MPU roadmap. On the left is the STM32 MP15, which was released in 2019. We followed that up with the STM32 MP13, which is a very low-cost applications processor. Both of these are 40 nanometer processors with 32-bit instruction sets that are based on the Cortex A7 and Cortex M4 cores. We're now released the STM32 MP25. We will follow that up with the STM32 MP23 later this year, and then the STM32 MP21, which will be available early next year. These are 16 nanometer processors based on a mix of Cortex A35 and Cortex M33 cores and support a mixed 32-bit and 64-bit instruction set. Once the MP2 family is fully released, we will then focus on our next generation of MPU products. The STM32 MP2 microprocessor series has a rich and robust set of features and peripherals that make it a great solution for a mix of applications, which we will see on this next slide. The MP2 also includes advanced compute capabilities and strong security features, which we also highlight. The MP2 family was designed for highly connected applications. This includes industrial and factory automation, such as gateways, PLCs, metering, and barcode readers, in smart homes with gateways, HMIs, white goods, and doorbell applications, and smart city and infrastructure such as power grid, EV charging, and metering. Some potential AI applications include anomaly detection, people and object detection, facial recognition, voice recognition, traffic management, and energy management, just to name a few. All of this is built on top of our security features to enable secure boot, firmware and data encryption, and context isolation. The STM32 MP2 is part of our rolling 10-year longevity commitment and has an extended operating range to help service the high demands of industrial applications. The STM32 MP2 can operate for 10 years while always on from -40 to 125 C. That, combined with our world-class supply chain support, ensures that the STM32 MP2 is an excellent choice for your application. We also give you flexibility to allocate resources according to your requirements. Processor tasks can be split between the single or dual Cortex A35 cores that can operate up to 1.5 GHz, or the Cortex M33 core that can run up to 400 MHz with flexible boot options. And again, all of this is built with security in mind to keep your solution safe. The STM32 MP2 is a 64-bit MPU with advanced edge AI capabilities. It is our first processor with a dedicated hardware AI accelerator, and it can operate up to 1.35 TOPS. It has flexible AI ecosystem that allows it to run on the CPU, GPU, or the dedicated AI accelerator. In addition to that, we do have a rich set of multimedia features for high-end use cases. There's a 3D GPU that can support up to 1080p resolutions, full HD video pipeline with RGB, LVDS, and DSI outputs, and also a MIPI CSI2 camera interface with imaging pipeline. In addition to the features I just mentioned, there's also a lot of interfaces to offload the CPU for connected applications. In the middle there, you can see the Cortex-A35 core, and on the left, there's the video processing unit for video encode decode, the Cortex-M33 core for real-time processing, the dedicated 2+1 Ethernet switch with TSN capabilities, and then on the right, we have the GPU with the various display outputs going through the display controller, and a dedicated image signal processor for camera inputs. This is in addition to what you would usually see on an MPU, which you can see on the bottom there, the UART, USB, timer, ADC, CAN, or even a PCIe interface. And as I mentioned, this is all built on top of our enhanced security features. This includes Trust Zone, which is available on both the Cortex-A and Cortex-M core on the STM32 MP2 device. This enables secure boot, secure firmware updates, and cryptographic operations. It is also included as part of our secure secret provision ecosystem, and we also provide edge confidential computing thanks to our resource isolation framework. All of this allows us to get to the CCIP 3 and PSA Level 1 certifications. Some more details in the security overview on the STM32MP25. We have memory and peripheral protections against illegal access control. That's part of our resource isolation framework. There's a secure crypto accelerator that does prevent physical attacks to allow the security on your product to be more robust. There's device authentication attestation during the full product lifecycle, and also code isolation for runtime protection. And as part of our STM32 Trust ecosystem, we have Opti, which is a trusted execution environment that provides security services during runtime, the in-factory secure secret provisioning capabilities to allow you to provision your device during manufacturing, and it's part of our Cube framework for MPU that includes signing and key generation. Here we can see a great overview of the Delta features between the various STM32 devices. On the left, we have the STM32MP25, which again is a dual Cortex-A35 core that can run at up to 1.5 gigahertz. There's also the 400 megahertz Cortex-M33 coprocessor with the GPU, MPU, and VPU to offload tasks. You can see the capabilities of each peripheral there. The VPU is a H.264 1080p video encoder decoder. We do support low-power DDR4 and a 32-bit interface on this device. On the display interfaces, you can see we have the full options of LVDS, MIPI, and RGB. On the CAN interface, in addition to the MIPI, the CSI interface that I already mentioned, there's also the 14-bit parallel interface. The MP25 does also include the 3 Ethernet TSN switch in a 2+1 configuration, and a PCIe port that could also be used as a USB 3, and then a standalone USB 2 interface, in addition to those 3 FD-CAN interfaces. As we go to the right, in light blue, you can see the Delta features. The STM32MP23 is still based off the dual Cortex-A35s at 1.5 gig, and the Cortex-M33 at 400 megahertz. And then we can see on the GPU, NPU, and VPU, it's roughly half performance for the GPU and NPU. And then we drop the encoder and have decode only on the STM32MP23. The DDR interface on the MP23 family is a 16-bit interface, and we go from a dual to a single LVDS interface on the MP23 family as well. Further down on the connectivity, we go from 3 TSN Ethernet ports to 2 TSN-enabled Ethernet ports and 2 USB 2 devices, along with 2 CAN interfaces. The MP21 is the lowest cost option, with a single Cortex-A35 that runs at 1.5 gigahertz, and the coprocessor, the Cortex-M33 coprocessor, can run it up to 300 megahertz. We do drop the GPU, NPU, and VPU accelerators here, but still support the 16-bit DDR4 interface. Since we dropped the GPU and VPU accelerators, we also drop the LVDS and MIPI DSI interface, but still provide a parallel RGB 24-bit interface to still be able to provide rich graphics onto a display. The camera connectivity options are similar to the MP23 in the MP21 family as well. Here we have the full STM32 MP2X lineup. On the left, you see the MP25, which is available today, the MP23, which is coming out later this year, and then the MP21, which will be available early next year. The You can see it's a mix of single and dual Cortex A35 cores. They do all have the Cortex M33 coprocessor. While most devices have 2 Ethernet ports, the MP257 on the left has 3, and the MP2X1 devices on the bottom row there have a single Ethernet port. And you can see the delta features between the families. All of this is designed with you in mind to have flexibility and options to pick the best part that's right for your application. On the bottom half here, we can see the various packaging options. The largest package we have available is the 18 by 18 millimeter package in a 0.8 mil pitch BGA with 172 GPIOs. The smallest package on the bottom right there is the 8 by 8 millimeter BGA package in a 0.5 mil pitch BGA. You can see the rows across imply pin compatibility. So the 10 by 10 BGA 361 package, you could potentially go all the way from an MP21 to an MP25 without modifying your PCB. You'll also notice the dashed line will delineate the 32-bit versus 16-bit DDR interface, and then the top and half, the gray and the white sections specify the PCB requirements. So on the top half, we have a 4-layer PCB that can be done with through-hole vias. And on the bottom half, a minimum requirement of 6-layer PCB with a high-density interconnect or hidden vias for your application, but it does allow for the smallest solution size. All of this is provided with the same ecosystem that is software compatible from start to finish. In addition to the MPU itself, we also have a power management IC, the ST-PMIC25, which is specifically designed for the MP2 family. It is optimized for power consumption, potential BOM savings in your typical applications, and also a small PCB footprint versus a full discrete solution. There's more information available on this online, and I'll talk about a little bit more on an upcoming slide. One thing I will take a moment here to highlight on this slide is the power consumption of the MP2 family. In general, what we see is it's best in class for relative to other devices in this product category in terms of overall power consumption. It's extremely power efficient with the Cortex A35 cores and allows your overall system design to be much simpler, whether you're using a battery or you're just in an enclosure and you're trying to avoid thermal runaways. The MP2 family is designed with that in mind. And here we have the full STM32 MP257 block diagram. I won't go through every component here, but you can see I will mention some of the highlights. Again, this is based off the 257, which is the most fully featured device. On the top left, you have your usual system applications with up to 172 GPIO, 96-bit unique ID, the CRC check, crystals, and internal oscillators and power regulators. On the security side, we do have on-the-fly encryption on one of the octal SPI ports and also on the DDR interface. You can see there the crypto accelerator, SCA is side channel attack resistance. In addition to that, we have the SHA and HMAC accelerator and PKA and ECC and RSA algorithms. We do monitor for temperature, voltage, and frequency and the 32 kilohertz detection to prevent anything like brownouts or hardware tampering with a secure real-time clock and a true analog random number generator. On the very top of the security block, you see the resource isolation framework. This is what allows us to make sure that the device is used as intended. For those of us that are familiar with Linux, the best analogy I can probably give you is it's similar to an access control list that Linux does in software. We implement this in hardware on the MP2 family. Below the security block, you see flexible audio interfaces and control interfaces, or control timers, I should say. There are 16-bit motor control timers with PWM synchronized AC timers and flexible 16, 32-bit and low power timers. On the top right, you see on the connectivity, the 2 gigabit Ethernet TSN with switch. If it does have the switch, you do get that third port. Up to 3 CAN interfaces in the MP2 family, 3 SDIO ports, a NAND interface, 2 octal SPI ports, again, one of which has on-the-fly encryption, decryption, various UARTs. We do have a PCIe interface that can be used as a USB 3.0 interface. If you use the USB 3, that is essentially how you're using the PCIe. If you don't need USB 3, you can put PCIe on the board. Our eval board has both on it. In addition to that, we do have a standalone USB 2.0 host controller, and we do support the Type-C connector support. And on top of that, we have your usual suspects of I2C, SPI, and UARTs. We do have 4 I3C interfaces on this device as well. Then on the multimedia side, you can see the AI accelerator and GPU accelerator that I've already mentioned. The GPU does support OpenGL ES 3.1, Vulkan 1.3, and OpenCL 3.0. The video encoder, I think I mentioned earlier, it does support 1080p 60 with H.264 encode and decode. And then the various display options that we've mentioned. On the camera interface, we do have both parallel and MIPI interfaces with a dedicated image pipeline. There are 3 12-bit ADCs that can go up to 5 megasamples per second and temp sensor on here for the analog side. And then focusing on the cores again, the dual Cortex A35s that up to 1.5 gig with the Cortex M33 at 400 megahertz. There is on-chip SRAM here to allow for code execution on chip and accelerated execution with caching. Both the Cortex A cores and M33 core do also support trust zone. On the DDR side, we do support DDR4, low power DDR4 in a 32-bit or 16-bit interface that can run it up to 1.2 gigahertz. And then also a DDR3 or DDR3L at 32 bits or 16-bit interface running at 1066 megahertz. And now I'd like to talk to you a little bit more about our STM32 ecosystem and how it can help reduce development time and cost with our MPU portfolio. We do several things to try and help accelerate your time to market. That includes making development boards available with PCB layout examples, hardware configuration tools, and then the software development. We try to get you started with our embedded software tools with the STM32Cube ecosystem and flexible software offering. We do provide a Yocto build environment. And then on the manufacturing side, in the STM32Cube programmer, help do things like generating keys, assigning tool, program the OTP memory, and also the onboard flash. We do have more information available about this on our wiki site, and we have many partners, tools, and ecosystems available as well, including SOMs and software services. Here we can see the development tools for the MP2 series. On the left, we have the eval board, the STM32 MP257F-EV1. We do provide an LCD panel display as an add-on. There's also a camera module adapter board that does include MEMS microphones and MEMS sensor, and a DSI to HDMI adapter board. These are all available now. The MP257 ships with a power supply. The display, camera, and adapter board are all available separately. We will be releasing a discovery kit very soon, the STM32 MP257-DK. There's more information available on our website today. That will be coming in Q4. I do believe it will be the earlier part of Q4 in the October timeframe, November at the latest. There are more STM32-based dev tools also available through our partners as well. For embedded software, we have our Linux distribution. We ship it in 3 flavors: the starter package, developer package, and distribution package. The starter package is designed to very quickly and easily get started with our development boards. It's essentially pre-built binaries, allows you to flash the image to the board and get up and running very quickly. With the developer package, you can start to add your own code on top of the MP2 embedded software distribution. You can also start to add your own layers and packages that are needed for your application. The distribution package is available to create your own distribution, which would essentially allow you to create your own starter or developer package, but really does allow you to have the most flexibility and to create the Linux distribution that's ideal for your application. One thing I will highlight here, we do take all of our driver code and mainline it to the Linux kernel. So we try to be as flexible as possible here. So you can use our Linux distribution, or if you prefer, you can go your own route and go and pull the drivers from kernel.org and start from there instead of our starter or developer package. Our OpenST Linux distribution is on a rolling 2-year release cycle that follows the long-term support kernels. So you can see OpenST Linux version 4 was Kirkstone version 4 for Yocto. OpenST Linux version 5 was Mickeldor, and then version 6 was ScarfGap. Right now, MP2 family is, if you download it today, is the 5.1 release with version 6 coming very soon. So it's 2 kernels with 2-year support that overlap. And this will be a rolling commitment that you'll see from us in the future. On the software development tool side, we have our STM32CubeMX tool, which hopefully you're already familiar with. It does allow for device tree configuration, but maybe more importantly, an initial device tree generation, and also a DDR tuning tool. The device tree generation, obviously we can't give you the full device tree for your application, but it is a great starting point. And then we also provide the device trees for our eval boards to allow you to look into see how we've configured ours as well. The Cube IDE allows for OpenST Linux developer package support, and also the DRAM tuning tools available in there as well. You can build Linux from within Cube IDE if you don't, but most Linux developers do prefer to do that via the command line in a more Linux-centric ecosystem. And then finally, we have the STM32 programming tool. The Cube Programmer does allow you to do things like program into Flash, DRAM, and or system memory. It allows you to program the one-time programmable memory, and also helps facilitate signing and key generation tools. Another excellent feature that we have is our PCB examples. So these are designed to be plug-and-play solutions for MP2 projects. We do we essentially do the DDR layout, the SoC layout, and include the PMIC and the Flash in the layout example for you. All of the different BGA packages have been done, includes the PMIC, Flash, and various DDR types, with signal integrity and power integrity checks already completed. You can reuse this for your own layout, copy and paste, and implement what makes sense for your specific application. And again, these are available for download on our website today. To extend the capabilities of the device further, we also have advanced HMI capabilities with stunning graphics. There's multiple graphical libraries that can run on the MP2 family. This includes GTK, LVGL, and Android via authorized partners such as Embedded Wizard, Candera, Qt, and Crank. We try to be as flexible as we can here so that you can implement what makes sense for your application or what you've done and worked with in the past. And then to extend the features and capabilities of the MP family, we have expansion packs as well. So you can see some of these are still planned and some are available today. All of these expansion packs will be available on our website, free to use, no royalties required. I'm not going to go through the full list here, but you can see it includes some cloud connectivity with Microsoft Azure and Amazon AWS. Sometimes we do help facilitate our own components, such as the X-Linux NFC package, the GNS package as well. We have an AI package that I'll talk about here in the coming slides. The X-Linux RT package, that enables the real-time kernel mods, and it's a real easy way to pull that into our OpenST Linux distribution. For those of you that aren't familiar, Linux RT is designed to improve the lag and latency of the Linux kernel to make it appear more real-time. Just bear in mind, real-time can mean different things to different people. So I do encourage you to test out the features and functionality there. And bear in mind, we do have the Cortex M33 code processor that is much closer to true bare metal and provides a more consistent response time in terms of real-time applications. And moving to the right there, you can see some more planned expansion packs we have available, including the TPM, which is our Trusted Platform module. We're going to have a TSN expansion pack available to bring out the full features of the TSN-enabled Ethernet ports on our device. And I believe actually the X-Linux Qt package is available today, if I'm not mistaken. So now I'd like to take a minute and focus on the AI accelerator in our expansion pack. The idea with the Linux AI expansion pack is to seamlessly integrate AI into your MP2 products. So we do that. There's three main steps: train, benchmark, and optimize, and then create your apps and deploy. For training, you can bring your own model, or you can start with one of our example models, which we call ST Edge AI Model Zoo. If you have your own model, that's great. We can run it on the hardware. If you want to just test out the AI applications and see what can really be done, we do give you a number of potential examples with the Model Zoo to get up and running very quickly. The next step there would be to benchmark and optimize. We actually have two versions of this, one on the desktop and another in the cloud. The desktop version can be run locally. If you have any models you want to upload to the cloud, which is very understandable, you can definitely run that on a local desktop version. The cloud developer option does quite literally have a server farm where we run your models on STM32 targets to give you inference times and real world performance numbers. The cloud version is also the only one that can do the model quantization. So if you're doing optimization, benchmark service, and model conversion, that can be done on the desktop version. The quantization needs to be done on the cloud. Once you've gotten there, you can take your application and deploy it by pulling in the Linux AI package into the OpenST Linux distribution, and that pulls in all the key components that are needed to help run AI applications on our STM32 MPU platform. So we have an MPU AI compiler with two options. Again, I already mentioned you can do it on the cloud or you can do it locally. The desktop version can manage the optimization, benchmarking on a board if you have one, and also the model conversion. The cloud version can do that. In addition, it can also do the quantization. And again, you can bring your own model if you have it. We do have a number of examples with our Model Zoo, and we have a number of supported AI models with TensorFlow and Onyx, and AI formats with the int8 quantized per tensor and per channel, and also the dynamic fixed point 16-bit running on the GPU. The target AI engines is the NPU, which again is preferred since it is our dedicated AI accelerator. You can also fall back onto the GPU or run AI models directly onto the CPUs. And this is a good overview of what is included in the Linux AI package. Again, it's part of our overall open ST Linux distribution to provide the expansion pack. And what is included here is the AI frameworks needed to execute neural network models, a selection of example applications, the model benchmark application tools that we use for our MPU product, and also the tooling frameworks, Python 3, GStreamer, OpenCV. These allow you to develop your applications very quickly. It is MPU agnostic. It's compatible with all of our MPU products. It will just take advantage of the underlying hardware as best as it can, which in the MP2's case does include that AI accelerator to give you a kick in performance. Again, delivered as part of our OpenST Linux distribution and tested and improved to work on both the eval board that's available now and the upcoming Discover Kit available soon. So I hope you enjoyed that presentation of the STM32 MP2 family. We have lots more resources available on our website. I do encourage you to reach out to look on our website. There are samples and boards available now, and reach out to your local SD contacts to learn more. Thanks for your time.
Thanks, Mina, for that great presentation. We already have several interesting questions, but I want to let our audience know that there's still time to submit your questions. Okay, Mina, are you ready to answer some of these questions?
Yeah, absolutely. Thanks for having me, Jeff.
Excellent. Very basic question. When will these devices be available?
Yeah, so thankfully we can finally say that they're available now. They were released fully orderable last month. Initial demand, especially for our boards, has been pretty high, so we're working on making more of those available as soon as possible. And as I mentioned during the webinar, we also have a discovery kit that will be available towards the end of October or early November, which should help with availability. I know right now it's a little bit of a challenge to get some of the boards, again, because we've had such high initial demand for the product, but everything's fully released and available. Boards and samples are available now.
Excellent. I know with so many resources out there, sometimes it's hard to know when to start. The next question, what's the best way to get started with development?
Yeah, so obviously you want hardware, so we want to make sure you can get a board in your hands. But once you do have that, we have so much information available on our wiki site. For those of you that aren't familiar, it's just wiki.st.com. It is broken out into two sections, excuse me, with the MCU and then the NPU. Obviously, with our MP2 product, you would want to focus on the NPU side of that. And you'll find a lot of resources available on there, including getting your development environment up and running, how to get the boards up and running, and how to use the rest of our tools and ecosystem with our MPU products.
I know there's a lot of lists of features. The next question is, what would you consider the most differentiating features of the MP2?
Yes, so there's a lot of good answers here. It will obviously largely depend on your application, but few highlights. I think I'd like to start with the AI accelerator on the MP25, largely because it is the first ST device with a true dedicated hardware AI accelerator. But looking beyond that, the 2+1 Ethernet switch, some of the more advanced graphics capabilities, and the flexible connectivity options are all great features. And I mentioned this again during the webinar, but I do want to highlight that what I would describe as the sweet spot in terms of overall performance and power consumption in the MP2 family. This should help the overall system design, both in terms of current draw and heat dissipation. And not only that, but also the product lifetime in the field. So when you do deploy a product, maybe it's in an enclosure, maybe it's running out of a battery, the power consumption will greatly help with your overall system design and hopefully make your job as an engineer a lot easier.
Yeah, that sounds great. What's the maximum DRAM size with the MP that the MP you could support, and at what speed?
Yeah, so we have the MP25 that was released last month. That runs at 1,200 megahertz or 1.2 gigahertz. And then the MP23 and the MP21, those do go down from a 32-bit to 16-bit DDR interface. And the MP23 also runs at 1.2 gigahertz. The MP21 will run at 800 megahertz. And the maximum size, I'd have to double check this in the data sheet. To be honest, I do believe it's 4 gigabytes.
Okay. Next question. How do you interact or communicate with the Cortex M33 microcontroller?
Yeah, so one thing to highlight, development for the M33 core is done very similarly to what we do for our standalone MCUs, in that you can use the CubeMX tool and also CubeID. For CubeMX, that does facilitate the pin muxing and configuration of the device. It also does your initial code generation. And then the CubeID you will use for development and compiling. And we do provide our HAL drivers for the M33 core that is inside the STM32 MP2 family of devices. In terms of communication, we have open source tools to implement a mailbox passing system, and that's done in shared memory to allow for a high bandwidth. It's essentially a virtual serial port between the A35 cores and the M33 core. To do this, we utilize RP message, which is part of the OpenAMP project on the M33 core, and then we have remote proc running on Linux in the A35 cores, and we do have several examples to help show how to utilize this message passing system.
Got it. Next question. What are the boot options available?
Yeah, so this is actually a nice improvement over our previous MP1 generation of product. The MP2 allows you to pick the primary boot device using a combination of either I/O pins or the option bytes inside the device. So it allows you to select if you want the A35 core or the M33 core to be the primary boot device. And both of those will also support secure boot. One thing to highlight here is that both, or I should say the Cortex A35 cores can be powered down if you want to save on power while the M33 is still running, and can either interact with the environment or be an intelligent wake-up source, and also vice versa. You can shut down the M33 core and leave Linux running. This is to allow for flexibility in your design, so hopefully your application and use case can be done as efficiently as possible.
Got it. It looks like that's it for audience questions. I'm just going to toss in one of my own questions. I'm always very interested in where the cutoff is between a microcontroller and an MPU, and I know running Linux is an important thing, but I'm just impressed that the power is so low here that it seems like you can go into application you couldn't go with an MPU.
Yeah, so it's actually a fairly common question I get. The delineating line that I always use as an example is the memory management unit.
Oh, right.
You're talking on micros 1632-bit size memory bus size. On NPUs, it's a mix of either 32 or 64-bit, and that essentially defines how big of a memory you can access. For 32-bit, we're limited to it's gigabytes in size. An MMU, memory management unit, allows the hardware to abstract away the memory that it's accessing, essentially give you a much bigger space to work with. That plus what I would call the high-speed off-chip memories that aren't available in micros. So when you have DDR interface or eMMC type memories attached to this device, it adds more components, more complexity, but a lot more performance when we talk MPUs over MCUs.
Gotcha. All right. Well, thank you again, Mina, for that excellent presentation, and thank you for sticking around for the Q&A. Before we wrap up, I'd like to announce our prize winners for this session. So congratulations to Travis Lisk and George Shapiro. We'll be in touch with you within the next week to ensure that you have all the information that we need to send you your giveaway package. So thank you for attending Industry Tech Days 2024, and thank you to our event and giveaway sponsor. Our giveaway sponsor is DigiKey, and our event partner is Electronica. If you happen to be in Germany in November 12th to 15th, check out their Electronica trade show, and I'll be there as well in Munich, Germany. And in a moment, you'll be redirected to ST Microelectronics exhibitor booth, and I'll encourage you all to check out today's other live sessions, keynotes, and published content. Hello, everyone. Thank you for joining us again for Day 3 of Industry Tech Days 2024. I'm Dale Wilson, Director of Engineering and Content at All About Circuits, and I'll be your moderator for our next session, which is titled Breaking Barriers, Leadership Principles for Engineers. Let me tell you about our presenter. Jackie Maddox is the founder, president, and CEO for Women in Electronics. Jackie started her career working in the electronics industry during her college years. She graduated from Cal State University Northridge with a Bachelor of Arts degree in Communication and Journalism. She has worked in sales, distribution management, and strategic key account management. Jackie founded Women in Electronics in 2017, which is now a thriving global nonprofit 501c3 organization. Following the presentation, we'll have a live Q&A with Jackie. You can submit your questions at any time during the session using the chat box on the right-hand side of your screen. I briefly chatted with Jackie as we were setting up for the session, and she wanted me to encourage all of you in our audience to ask the challenging questions you may have, or in her words, discuss the topics that might make you squirm in your seat a bit during her presentation. So thank you so much for joining, and with that, I'll hand it off to Jackie for her presentation.
Hello, I am so excited to be here today. Thank you for joining this session of Leadership for Engineers, Breaking Barriers. Oh my goodness, super excited that you are here to join us, men and women, okay? So thank you for being here. I want to start by introducing myself. My name is Jackie Maddox, and I am the founder and CEO of Women in Electronics We United, as you see in the background, and I will explain that in a second. So I wanted to give a little preface of myself first to introduce myself to you. I have been in this industry, oh my goodness gracious, for many years, probably about 35 years now. I started in college and did not expect to find my place to call home in this industry, a technical industry. I was a journalism communication major, worked at the studios, loved that life. And then some life circumstances happened and I ended up here in the electronics industry and I fell in love with it. And why? Because of the people. Think of this industry. It's a very people-oriented industry, whether you're an engineer, a marketing person, an IT person, wherever you sit. This industry has a way of being a very small town feel, although it's a vast industry. So hopefully you're making very good connections, even being on this webinar and being a part of this program, that you're connecting with people and really taking advantage of all the support and all the connections around you. But anyway, that was the part of it that I loved so much, was the community and the people. So I ended up staying in the industry all these years. I took a period of time off to raise my children. And when I came back into this industry after taking a period of time off, I was expecting when I came back that there were going to be more other people that looked like me, right? And maybe some younger people than me. I was always the youngest one at the table at all these executive conferences. And to tell you the truth, I was the only woman, but I never really realized it at the time because I didn't have any real issues. But it's when I came back into the industry and I went back to an executive event and I was still the youngest one and I was still one of the only women. And I was like, what is going on here? It was the first time it really hit me. And I was a little concerned. I was concerned about succession. I was wondering what the plan was. This industry is a very innovative industry. We impact the globe with what we're doing here. And so it's kind of like failure's not an option, right? Like we got to get this figured out. And it just didn't seem like people were really noticing what was happening here. And so I started Women in Electronics because I would go around and meet all these amazing people, but then I'd see the women too. And I'm like, wait a minute, why are you not at that table? I don't understand. And so this is why I started Women in Electronics, is to gather men and women together to say, okay, Houston, we have a problem. Let's talk about this. Let's not work against each other, but let's work for each other and with each other to understand that we're all going to benefit by getting more thinkers to the table, more qualified people at the leadership tables, making critical and important decisions that will impact the globe. So let me just start with that. Why would you men participating right now? Why would you be interested in coming to a session like this? Well, obviously, number one, maybe you're caring about leadership. Maybe you're thinking about your career, and that's an amazing thing, men and women, to be both thinking of that. But why is this such an important initiative, Women in Electronics, now moving over to We United? Why is that important for all of us? It's because of the relative returns. It's because profits go up when we have diverse-minded people at the tables. So when we include women and elevate women to leadership roles, just to point out, it does not take the job of somebody else. We're elevating somebody who's very qualified, who's earned that position. And we have found through research and data, it's an expansive effect. There is room for everyone. There is room for everyone. And when women get elevated into leadership roles, we see an expansive effect. So let's just start with that to say we have men and women who are very qualified and talented and should be at that leadership table. At large, at this time, our figures for women electronics, we started in 2017. When we look at the entire supply chain channel, manufacturers, distributors, contract manufacturers, the whole aspect of the channel now are digital solutions providers. We put all of them in the mix too. With everyone combined, it looks like around a 15%. We're running our final numbers with all the research we've been doing, but it looks like 15% or lower. Looks like or lower. When we first started, we were 15% women in leadership roles, decision-making roles. So you might look around and see many women in the industry, right? You probably see women everywhere and you think, oh, check that box, everything's good. No, it's not good. Because we're not seeing those women advancing to leadership roles, decision-making roles that impact an organization. That's what we're trying to impact at Women Electronics now as we move to We United. The profits, the relative returns go up 19% on average when you have parity at the leadership table. So when you look at our industry, you look at even this past year, it's been probably one of the most challenging years I have ever seen in my history of my career in this industry. And it's really amazing all the cost-cutting measures we go through. If we could pay attention to the data, and please go on our website, womenelectronics.com, go to About We, corporate presentation, please look at the data and do your own research. We highly advise you to be critical thinkers, do your own research, look at the data, check, recheck, and make your own decisions. But the facts and data that we have researched and seen at large is that your relative returns will go up on average of 19% with parity. So you can expand that. The more diversity you have at your leadership table or in your team, if you're developing a team, the more diversity you have, the better decisions you're going to make and the more relative returns. So I want to throw that out there because here we are talking about leadership for engineers and what is it that's going to make you go to those next levels and how are you going to create successful teams? Keep in mind diverse teams. So I also wanted to say that they don't always teach you in engineering school how to lead. So engineers typically, and we might have other people, and please stay with me if you're marketing, IT, any other positions, this applies to everyone. I'm actually focusing on engineers a lot because I know that we have a lot of engineers here. And I want to, just challenge you to question yourself. If I'm good at being an engineer, can I lead that position? Can I lead a team of engineers? That skill set is very different. And I find that what happens is that you might be great at being an engineer, but nobody has fully trained you up in how to be a leader. And this is where things start to get a little shaky. So what I'm going to do is challenge you today, wherever you are, to be thinking of leadership and to be thinking of everything involved. And we're going to go through some of that today. What is involved in being a leader? How am I going to lead my position? And that steps into a whole nother skill set. So wherever you are, you might be marketing, you might be in all different aspects of the supply chain channel. But are you thinking of leadership? Because if you're really good at what you do, somebody's going to tap you on the shoulder and you will start to rise into leadership roles. You'll be doing less of what your traditional engineering, and you're going to need other skills developing. So I'm highly encouraging you to be developing these skills. This is part of the why for we created a program where you could come in and every single month get some type of leadership development. We have massive archives. If you don't know where to start here. We have everything you need already. If you want to be a part of our community, we've made it super affordable for anybody, whether your company reimburses you or not. That shouldn't be the question because it's wildly inexpensive for what you get. Go to womenelectronics.com and join. Go look at all of those modules we have on our website and see what it is that's going to help you develop as a leader. We have a mentorship program, a global program. Come and be a part of that mentorship program. Get mentored up in leadership. Very important. So I'm highly encouraging everyone to know that the leadership is in the gray. So when you're an engineer, there's typically a lot of black and white. It's facts, it's this or that, it's science, but leadership is in the gray. So I want to challenge you today to think in the gray. What are the solutions for this problem? It could be directly applied to engineering as well. Usually there is a solution in the gray. So I really want you to consider that. So We United, you see the sign behind me, is all about men and women coming together. We've moved beyond women in electronics because the benefit of parity impacts everybody. The relative returns are so great and so overwhelming, we have to get everybody on board. When we have to look at this together as an industry and for this very critical topic. So if I could leave you with anything today that I feel will most impact you and most help you, it's a leadership style. So as you're developing in your leadership, if you could develop a style of civility, ethics, and humanity, you will be a great leader. And it's really a lot simpler than most people make it out to be. Leadership is a big job. But if you could lead, let's start with the civility. What does civility mean to you? Have you ever stopped to think in this fast-paced, fast-moving world? What is civility, right? And do people really demonstrate that? If you look at our social media, you look at our world, you look at our politics, oh my goodness gracious, people are just not civil anymore. And civil behavior is basically politeness. It doesn't mean you always have to agree with somebody. It just means that regardless of the way somebody else behaves, you are showing up with very civil behavior. You are showing up contained. You are showing up never disrespecting or dishonoring anybody, but always presenting your best self forward. And that's civil behavior. Offering respect where respect isn't even due sometimes, right? Offering honor where honor isn't even due sometimes. And so it's just a matter of not participating in bad behaviors, really. So civility and leadership is essential. And it's the road less traveled. If you look at our world, it's the road less traveled. But I'll tell you, the data supports that civility matters, and civility especially matters in organizations. There's videos out there about civility. We are just releasing some in our Weekly. If you're not a member, just go and join our mailing list and get our newsletters every week. We release information all the time. But do some research on civility and the impact of organizations and cultures, and you will see the detriment. So if you are somebody who wants to go into leadership roles, first and foremost, always keep civility in mind. Ethics is another aspect of our We United leadership style. If you are an engineer, you are really, really good at science. You're good at figuring things out. You're good with solutions. Always be thinking of what matters to you. What is it that got you into engineering? Or if you're a marketing person, what is it that got you into marketing? If you're a product manager, what got you into that? Think about it, like what matters to you in the world. I don't think most people sit back because what you do for a living somehow came as a result of what matters to you. So for instance, I'm leading women electronics. What matters to me? What are my values? Well, guess what? One of my top values is fairness. That is something that's always been so important to me. Like I probably feel like I should have been an attorney or a judge or something, but it really matters to me in life. Fairness, treating people with kindness and all these things. It just matters to me as a person. And there you have it. I started a organization that's global, Women Electronics, now We United, advocating for civility, ethics, and humanity, applying my passions, applying what I'm born here to do on this earth to giving back to others. So I want to challenge you right now to think, what are your values? What is that stirring in your soul? What is it that sometimes you can find your values through what makes you upset? What is it that could get you going and makes you so angry? What is that? And then you can determine your values. So for me, if I see somebody being mistreated that doesn't have the ability to defend themselves, like say an animal, right, is being abused, or a child, nothing, I just can't take it. I literally can't take it. And so it shows the value for me of fairness and equity. So what is that in you? So I challenge you to know your values, because then that's going to help you with that ethical behavior, right? Knowing values, knowing what are the values in general, a lot of people encompass, right? We all believe you shouldn't steal and things like that. So if you're leading with ethics, you're leading with moral behavior. You're leading with a moral compass. I'm going to say that the higher people go in their leadership journey, sometimes they forget these things. And so I want to encourage you to remember this as you're going on your leadership journey, to always remember, no matter what position you take, you become more of a servant. So you don't have, you have more authority, leadership authority, but it's how you exercise that demonstrates if you're the type of leader who can lead with ethics. Super critical. And the data supports that you will be more successful. It is the road less traveled. It is the harder route, and you will have to go against the grain more. But that will help you in the long run in your career. And it will also help you be more true to who you are as a person. And then we get to humanity. And why does this matter? Why does humanity matter? Well, we can see in our globe. We can see in our globe why it matters. So be that leader who just offers this kindness. If we can put it in simple terms, kindness, human decency. If you come to a point where you have to terminate somebody, how you do that matters. If you are able to approach somebody in a human way, and sometimes I find the best things sometimes I've done for people is to let them go. Leadership is not all about, it's not all rainbows and butterflies, and it's not all about giving everybody what they want. It's about doing the best for the organization and meeting your goals, and to leading in a way that's going to get the majority where we all need to go. But sometimes there's just people on that team that are holding things back, and that you've tried and it's just not the right fit. And sometimes it's the biggest grace you can give them in life is to let them go, but with human compassion and kindness and honor and respect. So wanted to explain more about We United. So we are men and women coming in together to have thought leadership, talk about real industry topics with civility, ethics, and humanity. So with that, I also wanted to bring up this concept of SQ. So as we're leading and as you're thinking of leadership and wherever you sit, there's all these different quotients. So you've heard of the intellectual quotient, your IQ. Mostly everybody, hate to tell you, is the same IQ. The majority of all of us have the same IQ. Here I was, a communications major who didn't have a double E, but could start designing in products with the end user. So if you're committed, you want to learn, most of us can learn anything. So those of you that have been trained in all the technical, encourage you to be trained in the leadership in all these other quotients that I'm just about to tell you. So intellect, you have the intellect. We know that you're smart. You can learn this. And then there's emotional. There's the EQ that you hear about. All you have to do is Google, tons of resources out there. Go learn about EQ. We even have a ton available through our We United program. So come in and learn, or go Google and find out about EQ. This is probably the #1 skill you're going to need in order to be a very effective leader. If we're going to lead with civility, ethics, and humanity, we need a lot of emotional intelligence, and we need to be able to encourage and help others with theirs. So would highly encourage you to learn about emotional quotient, EQ. The other thing is AQ, adaptability quotient. So our adaptability is highly linked to our emotional intelligence. So if you're not an emotionally intelligent person, you're very stubborn, very set in your ways, you're not going to be adaptable to new ideas, solutions, concepts. Super important that we look at the systems we're in. There's a lot of systemic barriers to our world, right? And then applying it to what you're doing right where you are. You're in a system. So are you open to innovations to that system? Are you open to new designs, new solutions? The adaptability quotient, you'll see a lot of times, we know these leaders, we've all had them, where you pretty much don't want to make them mad. You don't want to say anything to go against what they're already doing. I highly encourage you not to be that kind of a leader. Be open. Doesn't mean you always have to take everything everyone says, but be curious, be open, encouraging change. The only thing constant is change. So I highly encourage you to be developed in the adaptability quotient and to think of yourself and where you are in your emotional intelligence. How are you when somebody challenges you? How do you deal with conflict? What do your relationships look like? Because whatever you have going on in your personal life will get transferred to your business life too. Where are your areas of weakness? How was your childhood? You know, what beliefs were you brought up with, and what maybe false beliefs were you brought up with? What is it that you're working on? If you could come to the table, men and women, knowing that, working on yourself and growing yourself constantly, you will be a really great leader. These are the things that people don't always tell you. People, you know, we look at our industry and we look at a bunch of hard skills and a bunch of technical skills. It all comes down to the human skills. So please, all the success of the industry is going to be the success of you as an individual, looking at yourself and applying that to your leadership. And the final quotient that we talk about is the spiritual quotient. And this is not about religion, but there's a lot of neuroscience out there about this. You can Google SQ, spiritual quotient, and you'll see a lot of information about it. But basically what this says is it's your why, it's your purpose. Most people don't sit and talk about this in the business world, but again, could be nothing more critical than knowing yourself. So all of us have a purpose and a reason that we were brought here to this earth. There's something unique about every single person listening to this webinar right now. There's something in you that is meant to benefit the world. So as you're going into leadership, it's a matter of finding that magical thing about you. What's your superpower? What are you naturally good at? What's your passions? And what's your why? You know, why am I doing this with women in electronics? It's because I care and I love people. I care about fairness. I love the community in this electronics industry and related markets, right? Because we're impacting all of our end users, we're impacting our digital solutions companies. There's so many aspects, but when I meet the people, I love them. And in my heart and soul and my gut, for whatever reason, I'm the one who got this passion for leadership and for fairness and for this industry to be very successful in innovation. So that's a passion for me. What is it for you? It's going to be different than the next person, right? So what is it you're good at and you're passionate about, and how could you apply that to what you're doing? So we find with a lot of rising leaders right now, a lot of people don't know that. A lot of people don't know. What are their values? What do they want to do? What's their passion? How do they apply it to their work? We find by and at large, especially our rising leaders, actually haven't sat and answered these questions. Once you can, you're on your way. So what I want to leave you with also is, so before I get into my final 6 things I wanted to kind of leave you with, I want to say this first. As we're going along in our leadership journeys, I will tell you right now, I would not be here if it wasn't for my support system, if it wasn't for my allies, and if it wasn't for the community. So I also want to tell you, please don't do this in silo. Whatever you want to do, whatever that passion is, however you're going to help your organization, please have your people. Have people in your back pocket that you really trust and admire. These might be people that you worked with before, a prior boss, or people that just really have your back enough to tell you the truth, enough to give you very sound advice. I have some of my biggest advocates or people, they don't always tell me what I want to hear. They tell me the hard truth all the time, and that's what saves me. But it takes having emotional intelligence, being committed to the spiritual side of yourself, to put it all together and to think through it and to be adaptable and to apply it to what you're doing so that it's not only for you, but it's for the benefit of everybody. So if we take away from this webinar, I know we're talking about something that we probably normally don't talk about, but here's the 6 things that I really encourage you to think about. What is it you're really great at? What are your values? What do you want? What are you trying to accomplish, and how are you going to get there? And so the how is going to be super critical. So I'm going to pause on this third, what do you want? And I'm going to say, think of it like this. We just had our We Summit, and it was pretty amazing. And we had a lot of just very high caliber talent there. And we were talking about a lot of these same kind of topics. And we had a speaker who was talking about the first fruits and the second fruits. And if you look at the spiritual part of your life, what are you chasing, right? Really, some people say money, success, I want a nicer car, I want this, I want that. But really, that's a second fruit. The first fruit is, I want to impact the world. I want to do something of meaning. I care about the environment. I care about making other people's lives better. I care about making a breakthrough. Whatever those things are, those are your first fruits. The second fruits follow, but that's the SQ part. That's kind of the faith part of where it's not a religious thing. It's whatever religion you are. It's knowing that there's something greater beyond yourself. So what is your first fruit? What is the meaning, the values, the purpose, your why for being here on this earth? The second fruits follow. The money, the car, the house, the this, the that, all of that follows when you know who you are, you're applying your natural superpowers and your passion to what you're doing, and you're doing it for the right reasons. So if you're getting into leadership or you want to be in leadership, please be thinking about these things, because so many people are dependent on you behind the scenes having all of this in order. So we get to 4. What is your plan? Who are your mentors who are going to help get you there? Your sponsors, your allies. What is your actual business plan to get there? So if you look at your career, most people don't have a plan for where they want to be, where they want to get. And I say sky is the limit. Do not let barriers limit you. Do not let systems limit you. You are the one who is in control of your destiny. You own where you go. So if you have your passions in the right place, and you have your why in the right place, and you have the talents and skills, you will get there. Do not let others decide for you where you should be going, because the majority of people will halter you. You make the decision. Sit down. I encourage you today, right after this webinar, please write down your plan. Here's where I want to be, and here's an idea and a plan to get there. First step, talking to your manager. Hopefully you're at an organization where you have a manager who really wants to see you get where you want to go. Is where you want to go an option in your organization? And if so, what do you need to develop in order to get there? Start there. If you are in a situation where you don't feel you have that support, can you make a lateral move? I love lateral moves. I think they're some of the most effective moves you can make. You don't always have to leave a company, right? Companies, people leave people, not companies. But I would say if you're at a company you like, but you don't love your manager and you feel like you're not going to get the support and you're going to be halted, go for a lateral move, right? And the trick is to outlast them. That's really the trick. And that could be very effective. If that doesn't work, and if there's no options there, go somewhere where your values align with the organization and that you can bring your natural skills and passion to advance this company, right? And be a part of something meaningful and great. So those are just some suggestions. Make a plan. And then what will you do different? So I'm going to challenge you to think, don't think of things the way everyone else is. How am I thinking different? And am I thinking something in my soul that I just don't want to say? So, for instance, I was one of the only women for many years at my organization. And I always would think, oh my goodness, something's wrong with me because I don't see things the way they do. Like, I don't know what is wrong with me, but I completely think something very different. And then I finally realized, I mean, this was after years, I finally realized, oh my goodness, I don't have a problem. Maybe not all of my thoughts are the best, but they're my thoughts. And when I started sharing them with my organization, and people started catching on and people started taking some of those ideas and applying them, then we realized these were good ideas. The problem was I wasn't speaking them because I felt like I was the only one in the room with those ideas. So as long as you present your ideas extremely honorably, not having the expectation that anybody's going to do anything with it, but at least to get that confidence to start saying how you feel about something or what you've thought about, I think is really helpful for an organization. And that 19% of increase in relative returns I mentioned, the reason companies elevate in their relative returns with parity is because they start getting those ideas. All those times I didn't say something, all those times I had a stirring in my soul, but I just didn't say anything, that was taken away from the relative returns of the organization. So if we look at it, if you're looking at your leadership journey, be encouraging people to think, to critically think, to be able to come to you with ideas and suggestions, and surround yourself with people better than you. You don't have to have all the right ideas. You just need to surround yourself with the people who can bring all that to you. And I think that is the real success of leadership. And then beyond this, we're coming to a close and would love to take your questions soon. But how will you go beyond this webinar and lead with civility, ethics, and humanity? Even if you're not in your typical leadership role, which wherever you are, you're a leader because people are watching you. Leadership is just about influencing others. So whether you're leading a team or you're not, you're leading in some capacity now already. So how are you leading with civility, ethics, and humanity? And what are the areas you can improve? Because we all make mistakes. We all are a work in progress, and we all can improve. And with humility and strength and courage, it's an acceptance of our weaknesses as well as our strengths that make a good leader. So with that, I want to say thank you for being here. Appreciate your time and enjoy the rest of your program. Thank you.
All right. Thanks, Jackie, for that unique presentation. We do have several interesting questions in our queue, but I want to let the audience know that there's still time to submit your questions for Jackie. Jackie, you ready to answer some of these questions?
Sure.
All right. So the first one is asking here is, where do you think engineers typically struggle the most when they make the transition from a technical contributor to a manager?
Well, that's a very good question because a lot of us, as I said in the webinar, don't get trained up in leadership. We might be able to do a position well. Maybe you got tapped on the shoulder because you're a great engineer. Leading that same position is a completely different story. So I think that the challenge is in the human skills, right? It's not black and white. It's not science. It's actually, like I said in the webinar, super gray. So unless you're a leader who's very committed, it's like daily development of learning about the human side of leadership, learning what your values are and bringing that to the table, because we find at large, it's without fail. Whatever that person has developed or not, they bring to their teams. So if you're a very people kind of orientated person, you do have some natural skills. It doesn't mean you have all the skills. Are you educating yourself in emotional intelligence? Are you educating yourself in your values? How do you think of things? What do you want your team to look like and operate in? Do you have a diverse team? Do you even care about that, right? These are the things that nobody really tells you, but will directly impact your success.
Okay, thank you. The next question is asking about a research study that was published by the American Psychological Association found that, quote, results showed that men prefer working with things and women prefer working with people, end quote, and that those interests may play a critical role in the disparity of the sexes in the STEM field. So based on those strong differences in interests, should we expect that there may always be more men in engineering than women?
No, we should not expect that. I think that this is why we do these webinars, because it's such a critical question. I think a lot of times it's easy just to say, oh well, there's just not a lot of women in STEM. Oops, not a lot of candidates that applied for this role. Oh well, right? It's easy to just do that. The hard thing is to push against it, right? And just say, why is this? Why are we not seeing? So I also had a lot of experience before women in electronics in education and being involved in a charter school. In that charter school, we made the parity so strong of boys and girls getting the same education and the same encouragement in STEM. And we saw girls doing amazing, scoring very well, graduating in the top of math and science and all these things. But then you send them out into the world and all the systemic barriers kick in. So it's not that girls or women can't do it or not interested in it. Many times it's about confidence because they've been taught they should be interested in something else. Or maybe they push past all those barriers. What we find at the college level, many or most girls feel unwelcome. So say they're in engineering classes, and they are some of the few in those classes. They don't get invited to lunch. They're maybe not on the projects. We hear this at large of women in college in STEM in engineering. So basically, I would say if now we go into the workplace, right? And so now we've got fewer coming along, but it doesn't mean you can't find these women. It means that when you find them, you've got a major gem. You've got somebody super resilient and super wanting to contribute to the team. So I would highly encourage people to take the tactic of pushing back on hiring when you don't have a diverse pool. So the trick is to create a diverse pool of candidates, but hire the right person regardless of any demographic, right? You hire the right person, but you really want an equitable talent pool. So what does that mean? It means that it might take longer to hire for a position. You might have to look harder. You might have to push back with HR, depending on the size of organization you are. You might have to push back and say, no, I don't have a diverse pool to choose from. And once you start pushing back, it's amazing what you'll start to find. And the last thing that I'll say is,
we're shocked all the time with the talent that's already there. So many times people are kind of like this, like looking outside, but look under your nose, because most times a person is sitting right there that you've never considered that can do the job well. And a very somebody who's committed to the team, who has the ethics, humanity, all those things we talked about, they can be trained too. So we forget these things. Just as engineers are trained up in technical abilities, can actually learn to be amazing leaders with training with the human skills. Same with people who naturally have the human skills, can be trained in technical as well. So we have to think out of the box, right? We've got to start expanding our minds to address some of these systemic barriers.
Okay. Our next question says, as a leader, man or woman, what are some actions I can take to not fall into stereotypical notions of women in the industry? We don't always intentionally play to stereotypes, but how can we create awareness to not do so?
It's such a good question, and I'm so glad that was asked. Again, I think it comes back to knowing yourself and confidence. So, if one thing that we could say is where we see at large women suffering is confidence, because usually they, in a STEM related industry, in the electronics industry, for instance, usually the women are one of the only at the table, especially in a leadership role or in a technical role. So there's a confidence barrier going into it, but know yourself. There's a lot of research by Dr. Sean Andrews. You can go on our website under our corporate presentation and look at some of the data. And right there, we show the superpowers of men and women. That's just based on neuroscience, research, data. And women bring natural superpowers to the table. So if you know yourself, you're embracing your true natural superpowers, you will be very successful on that team. But it's a matter of having the courage to be yourself. Just like men, you have natural superpowers you bring to the table. And that is the combination of the two, the men, the women together, the magic of that. So that is where those 19% of relative returns I talked about, that's where you see the returns. It's the magic of the two rubbing against each other and coming up with those solutions. That's the increase in returns.
Okay. Well, it looks like we've covered all of our audience questions. Thanks, Jackie, for your presentation and for the Q&A.
Yay, thank you for having me.
Before we wrap up, I'd like to announce our prize winners for this session. Congratulations to John Lamping and Jason Leverett. We'll be in touch with you within the next week to ensure that we have the information we need to send you the giveaway package. And we'd like to thank our friends at DigiKey for sponsoring Industry Tech Days 2024 and these giveaways. And thank you to our event partner, Electronica. We hope you join All About Circuits and the EE Tech Group teams in Munich from November 12th to 15th at Electronica's in-person trade show. In a moment, you'll be redirected to the Women in Electronics exhibitor booth. Thank you for attending Industry Tech Days 2024. I encourage you to check out today's other live sessions, all the keynotes this week, and the published content in the exhibitor booth. Thank you, everyone.
5 minutes.
Okay, I'm standing by.
Sounds good.
Just a little over a minute, Jeff. Rob.
Cool. I am ready. Hello, everyone. Thank you for joining us for Industry Tech Days 2024. I'm Jeff Child, Editor-in-Chief on All About Circuits, and I'll be your moderator for this session. This session is titled Switch Mode Power Supply Matrix. Let me tell you a little bit about our presenter. Bob Carr has over 30 years of experience in the semiconductor industry, tackling applications like BLDC, lithium-ion battery management and charging, USB-C/PD, 10BASE-T T1S, gate drivers, inductive position sensors, wireless and wired communications, authentication, SMPS, DC-DC conversion, and power over Ethernet. Bob has 12 US patents and multiple publications and blogs. After the presentation, we'll have a live Q&A with Bob, and you guys can, in the audience, can submit questions anytime during the session using the chat box tab that you see on your right-hand side of your screen. So, thank you so much for joining, and with that, I'll hand it off to Bob for the presentation.
Hello, everybody. For an agenda today, we will begin with our switch mode power supply matrix from 5 watts to greater than 3 kilowatt, and that includes controllers, gate drivers, and switches. Then we'll move on to switch mode power supply block diagrams, a total of 11 of them, ranging from 5 watts to 3 kilowatt or greater, correlating to the above matrix. And again, that includes controllers, gate drivers, and switches, and we'll also have a one slider on our wide bandgap silicon carbide. And then we'll wrap it up with reference designs and a demo block diagrams, including USB-C power delivery for 65 watts and 100 watts, a 3 kilowatt power supply, followed by a 7.2 kilowatt onboard charger. So anything that plugs into a wall, from a coffee pot to a blade server, needs a switch mode power supply to convert AC power to DC power. But the problem is that many of these different power supplies, whether they're 5 watts to 65 watts, or moving up to like lighting or power tools, 70 to 200 watts, and you keep moving up the power tree, you know, the power levels, TVs, power e-bikes, charging e-bikes, where you're to 200 to 350 watt, or you go to 350 to a kilowatt for cobots, medical equipment, microwaves, or finally up to a kilowatt to 2.5 to 3 kilowatt, where you're looking at HVAC and white goods or a cloud server. They all require different power supplies based on the amount of power required. And it's tricky because the irony is that they all have the same topology, right? You have AC power on the left side, DC power on the output on the far right side. In between, you have a transformer, and on the left-hand transformer, you have primary side control, and the right-hand side, you have secondary side control. So they all share a common topology, but your choice for the controllers, whether it's power factor correction, active clamp flyback, quasi-resonant flyback, or synchronous rectifier controller on the primary side, or the secondary side, or the gate drivers you choose, or the switches you choose, MOSFETs, IGBTs, silicon carbide, or GaN, you know, there's a lot of decisions to be made to fit the right power supply to the right power level. So where do you start? And the answer is easy. You start with on semiconductors, easy to use switch mode power supply matrix on the next slide. So this easy to use switch mode power supply matrix is a guide, or a first order approximation guide, to help guide you through selection of the controllers, gate drivers, and switches based on the power supply. And so all the columns contain the controllers, gate drivers, and switches, and the rows capture the levels of power, where the bottom row is the lowest power and the top row is the highest power. And we see an NA, that just means it does not apply. You don't need anything. So we'll start here. For the very first 3 rows are 5 watts to 25 watts, 25 watts to 50 watts, and up to 65 watts. And you move over to the right, and wherever you see an NA, you don't need anything. But when we see a product, that's the product you would pick to build your power supply. And further on, I'll have a block diagram of each one of these rows so it's easier to visualize. So then the next set of rows, I have 70 watts to 200 watts, and we have two sets of rows, ultra high density and high density. Ultra high density means you pay a little bit more money, but you can shrink the footprint of your power supply for the same amount of power. The next set of power is 200 watts to 350 watts, where you have ultra high density, in the middle there, low profile. And so that just gives you some more options for the form factor of your power supply. And then above that, we have 350 watts to a kilowatt, ultra high density and high density. And finally, the top two rows are 1 kilowatt to 3 kilowatt or a little bit higher. Now, the first two columns capture the power density rating, either ultra high density or high density, or in one case, low profile. And then the next column is the rectifier. And you can see there's a number of products that you can use for your full wave rectifier, moving up and down the power levels for each row. And there is also a bridgeless. And so the bridgeless kicks in when you decide to use power factor correction, which is required for going over 75 watts. One of the options for a power factor correction is a totem pole PFC, where you don't need a rectifier. Now, a PFC, what it does sometimes with varying loads is the voltage and current goes out of phase. And that's why after 75 watts, you typically want to have a power factor correction. What it does is it basically puts in phase your voltage and current. And so for PFC, you can just have a regular PFC controller, which I've listed here, a number of different PFC controllers. And you'll notice I have NAs at the bottom under 65 watts because you don't really need a PFC until you're above 75 watts. So if you keep going to the right, that's the power switch Q1 that you would use with that PFC. Now, as I mentioned earlier, totem pole PFCs, which are very nice for efficiency and are typically used for higher power, would also have a slow leg and a fast leg switches. So these four columns capture the gate drivers and the switches if you plan to use a totem pole PFC. And so where it says NA, those are not totem pole PFCs, but where I have the gate drivers and the switches, those would be totem pole PFCs. Again, further down, I'll show the block diagrams, which is a better visual for all these different power levels. Next is the active clamp flyback. We have a couple of instances for the active clamp flyback. And then next is the quasi-resonant flybacks, and that includes the controller and the power switch, followed by the LLC, which are also controllers that are used, they can switch faster. And if they can switch faster, your passives, the inductors, the capacitors, and the transformers can typically be smaller. So you typically use LLC for your higher power, as you can see when you're getting over 200, 350 watts. We have our LLC controllers listed there, as well as the gate drivers and the switches. Now, finally, the column for the primary side, the last column, we have the switchers, and you can see those are all NAs until you get down to up to about 50 watts. And you can see we have a couple of switchers there for 5 watts to 25 watts and 25 watts to 50 watts. And those are basically flybacks with integrated power switches. And then next we go to our secondary side controller, where I've captured the controllers for the secondary side and their switches. And then finally, the last two columns is USB-C power delivery, where we have a number of different controllers and V-bus N-channel MOSFETs to enable the V-bus, to enable V-bus onto the Type-C connector there. So this is a summary of our easy-to-use switch mode power supply matrix. And the next group of slides, I'll walk through all these, each one of these rows, but in a block diagram format, so for easier visibility. Okay, now we're going to turn our attentions to a total of 11 switch mode power supply block diagrams from 5 watt to 3 kilowatt, correlating to the previous matrix slide for high density and ultra high density power ratings. Okay, for our 5 watt to 25 watt power supply with a DC output of 5 volts to 36 volts, at the AC input on the far left, the DF10S or the DF08S diode bridges are recommended for full wave rectification. In the secondary side, on the right, the NCP431 shunt regulator is a low tempo programmable voltage reference up to 36 volts with only 2 external resistors. The FOD817 optocoupler provides isolation feedback from the required Vout in the secondary side back to the NCP 107X flyback controller on the primary side in order to regulate the Vout with varying loads. The NCP 107X is a family of what we call switchers, which are flybacks with integrated power switches, in this case rated for 700 volts breakdown voltage, up to 130 kilohertz switching speeds. You can choose either the 1071, 1072, 1075, 1076, 1077, or 1079, depending on the required current limiting correlating to different power switch RDS(on). Please visit onsemi.com for more product information. Now, moving to our 25 watt to 50 watt power supply, the secondary side on the right does not change, but for the primary side on the left, we transition to the GBU4M or the GBU4K diode bridge for higher power. We also pivot to our 800 volt, 130 kilohertz switchers, the NCP 11184 with a 2.25 ohm RDS(on) maximum, or the NCP 11185 with a 1.3 ohm RDS(on) maximum, or the NCP 11187 with a 0.87 ohm RDS(on) maximum. And finally, moving to our 65 watt power supply on the primary side, we replace our switchers with the NCP 1345 quasi-resonant flyback, which operates up to 500 kilohertz and supports valley switching for improved efficiency. The NCP 1345 drives the NVD260N65S3 650 volt 260 milliohm external power switch. On the secondary side, we use the NCP 4306 secondary side controller to drive the FDMS86180 synchronous rectifier switch, rated for 100 volts, 3.2 milliohms. The NCP 4306 supports 7 amp sync current and 2 amp source current gate drive. And for USB-C power delivery applications, we offer the FUSB 15101 PD port controller, supporting up to 100 watts PPS or programmable power supplies from 3.3 volts all the way to 21 volts per the USB 3.0 PD specification. Next, we can look at the high density block diagram for 70 watts to 200 watts, where on the input of the primary side on the left, we select the GBU6M or GBU6K diode bridge, followed by the NCP 1623 PFC controller driving the NTP125N60S5H 600 volt N-channel 125 milliohm power switch. The NCP 1623 is a compact, robust, and feature-rich valley switching PFC controller with frequency foldback optimized to achieve high efficiency across a broad range of loads, while offering a complete suite of system-level safety protection. The NCP 1623 PFC is followed by the NCP 1343 quasi-resonant flyback, featuring a proprietary valley lockout circuitry, ensuring stable valley switching. The NCP 1343 drives the NVD260N65S3 650 volt 260 milliohm external power switch. On the secondary side, the NCP 4307 synchronous rectifier controller can be configured for high side or low side configuration. For 70 watts to 200 watts, we recommend the NTM FSC010N08M7 80 volt 10 milliohm N-channel MOSFET. For up to 100 watts, the FUSB 15101 USB-C PD controller is a great choice. And for ultra high density on the primary side, the NCP 1568 active clamp flyback can be used in conjunction with the NCP 51561 5kV galvanic isolated dual gate driver to drive two NTH L045N065 SC1 650 volt 32 milliohm silicon carbide MOSFETs. The NCP 1568 active clamp flyback replaces the RCD clamp snubber diode with one of the two SiC MOSFETs, improving efficiency while protecting the other SiC MOSFET power switch. Moving on to the 200 watt to 300 watt high density power supply, we are looking at either using the GBU8M or GBU8K diode bridge, followed by the NCP 1616 PFC controller driving the NVB190965S3F 650 volt 190 milliohm N-channel MOSFET. The NCP 1616 is a highly efficient and compact CRM or critical conduction mode PFC controller with high voltage startup capability. The current controlled frequency foldback technique enables superior nominal and light load efficiency. The NCP 1616 PFC drives the NCP 13994 LLC controller, which drives a half bridge consisting of two NVB150N65S3F 650 volt 150 milliohm N-channel MOSFETs. The NCP 13994 is a high-performance LLC controller supporting 700 volt startup, switching frequencies from 20 kHz to 750 kHz, quiet skip mode for reduced audible noise, and 2 amp source and sink gate drive. On the secondary side, we find the NCP 4318 synchronous rectifier controller driving two NTM FS6H82-4N 80 volt 4.5 milliohm N-channel MOSFETs configured in a half-bridge topology. The 4318 is an advanced synchronous rectification controller for LLC resonant converters with minimum external components. It has two gate driver stages for driving the synchronous rectifier MOSFETs, which are rectifying the outputs of the secondary transformer windings. The two gate driver stages have their own drain and source sensing inputs and operate independently of each other, and an advanced turn-off control algorithm allows stable synchronous rectification operation over the entire load range. As for the ultra-high density block diagram for 200 watts to 350 watt power supply at the bottom of your screen, you will notice the diode bridge has been removed or gone bridgeless. This is because we are using a totem pole PFC, in this case the NCP 1680, which jettisons the full wave rectifier for improved efficiency and smaller form factor. The NCP 1680 is a CRM, or a critical conduction mode, MCU-less state machine-based totem pole PFC controller that requires no firmware. So by design, the NCP 1680 simply knows exactly what to do. The NCP 1680, rated for up to 350 watts, drives two NVH-L065N65 S3F 650 volt 65 milliohm MOSFETs configured in a half-bridge topology, switching at the line frequency of 50 Hz or 60 Hz for the slow leg, and as for the fast leg, the NCP 1680 drives two NTH-L045N065 SC1 650 volt 32 milliohm silicon carbide MOSFETs configured in a half-bridge topology, switching from 120 kHz down to 30 kHz in frequency foldback depending on the load. The beauty of a bridgeless totem pole PFC topology is that any one given time, for the positive half cycle or the negative half cycle, there are only two devices in the conduction path. In contrast, a diode bridge PFC topology always has three devices in the conduction path. For our high-density power supply from 350 watts to 1 kilowatt, we return to a diode bridge using either the DFB20100 or the DFB2080. The NCP 1618 PFC controller drives a single NVH-L072N65S3 650 volt, 72 milliohm N-channel MOSFET power switch. The NCP1618 is an innovative multi-mode power factor controller. Depending on the current cycle duration, the NCP1618 autonomously navigates the optimal operation mode from continuous conduction mode, or CCM, to critical conduction mode, or CRM, or to discontinuous conduction mode, or DCM, with frequency fallback for an optimized efficiency over the line load range. In very light load, the circuit enters the soft skip mode. In addition, its high voltage capability eliminates the need for external startup and saves the permanent leakage they cause. Housed in an SOAC9 package, the NCP1618 incorporates all the features necessary for robust and compact PFC stages with very few external components. As for our ultra high density power supply solution from 350 watt to a kilowatt at the bottom of your screen, we revert back to a totem pole PFC bridgeless topology with the NCP1681 totem pole PFC controller. The NCP1681 is an MCU-less state machine-based totem pole PFC controller that requires no firmware. So by design, the NCP1681 simply knows exactly what to do. The NCP1681 is a multi-mode totem pole PFC controller, meaning it is capable of operating in fixed frequency CCM or current conduction mode, or constant on-time CRM mode or critical conduction mode, and valley synchronized frequency fallback for an optimized efficiency across the entire load range. With proprietary current sensing architectures and proven control algorithms, the NCP1681 allows for a cost-effective solution in a 20-lead SOIC package without jeopardizing performance. For our high-density power supply ranging from 1 kilowatt to greater than 3 kilowatt, we can use the DFB 25100 or DFB 2580 diode bridge. For PFC, we can use either the FAN 9672 2-channel or the FAN 9673 3-channel interleaved CCM or current conduction mode PFC controllers. Both devices fully comply with the IEC 1000-3-2 specification. Interleaved operation provides substantial reduction in the input and output ripple currents, and the conducted EMI filtering becomes simpler and more cost-effective. An innovative channel management function allows the slave channels to be loaded and unloaded smoothly in lower power level conditions according to setting voltage on the CM pin, improving the PFC converter's load transient response. Both devices incorporate a variety of protection functions, including peak current limiting, input voltage brownout protection, and tri-fault detection function. You will notice our LLC is located in the secondary side. I like to refer to the NCP4390 as a 2-for-1 because the NCP4390 is both an LLC controller and a synchronous rectifier controller built into a single device. The NCP4390 offers a wide operating frequency of 39 kHz to 690 kHz and is located in the secondary side. The NCP4390 drives two FDM S4D0912C 120 volt 4 milliohm N-channel MOSFETs in a half-bridge configuration in the secondary side. The NCP4390 also drives two NTH4L045N065 SC1 650 volt 33 milliohm silicon carbide MOSFETs, also in a half-bridge configuration in the primary side, with the help of an NCP51561 5 kV galvanic isolated dual gate driver, featuring 4.5 amp source current and 9 amp sink current capabilities. In this block diagram, the NCP51561 is not captured by an orange rectangle, and instead is captured by a small transformer symbol to signify the isolation between the primary side and the secondary side. As for our ultra-high density power supply solution from 1 kilowatt to greater than 3 kilowatt at the bottom of your screen, we revert back to a totem pole PFC bridgeless topology with the NCP1681 totem pole PFC controller. The NCP1681 is an MCU-less, state machine-based totem pole PFC controller that requires no firmware. So by design, the NCP1681 simply knows exactly what to do. The NCP1681 is a multi-mode totem pole PFC controller, meaning it is capable of operating in a fixed frequency CCM or current conduction mode, or constant on-time CRM mode or critical conduction mode, and valley synchronized frequency foldback for optimized efficiency across the entire load range. With proprietary current sensing architectures and proven control algorithms, the NCP1681 allows for a cost-effective solution in a 20-lead SOIC package without jeopardizing performance. The NCP1681, rated for greater than 3 kilowatt, drives two NVHL065N65 S3F 650 volt 65 milliohm MOSFETs configured in a half-bridge topology, switching at the line frequency of 50 Hz or 60 Hz for the slow leg. And for the fast leg, the NCP1681 drives two NTH-L045N065 SC1 650 volt 32 milliohm silicon carbide MOSFETs configured in a half-bridge topology, switching from 130 kilohertz to 30 kilohertz in frequency foldback depending on the load. The beauty of the bridgeless totem pole PFC topology is that at any one time, for the positive half cycle or the negative half cycle, there are only two devices in the conduction path. In contrast, a diode bridge PFC topology always has three devices in the conduction path. After reviewing the past 11 block diagrams and returning to the easy-to-use switch mode power supply matrix, I think one can appreciate and value the very comprehensive technology solutions that onsemi offers to switch mode power supply design, scaling from 5 watts to 3 kilowatt and beyond, with many high density and ultra high density options to fit your power supply applications. So one thing I would like to highlight here in orange is the many instances where the wide bandgap silicon carbide solutions can improve efficiency as well as reduce physical form factor in this easy-to-use switch mode power supply matrix. I want to point out that all of the SiC devices here are basically the same 650 volt 32 milliohm SiC device, where the only difference is the package. Where you do not see an asterisk is a 3-lead device, and where you do see the asterisk is a 4-lead device. On this slide, we take a closer look at the 650 volt 32 milliohm silicon carbide MOSFET that we earlier highlighted in orange in the easy-to-use switch mode power supply matrix on the previous slide. On the right, you can see a side-by-side comparison between the 3-lead and the 4-lead package options, where the 4-lead package offers a Kelvin sense pin for the source terminal. This improves the total switching losses, which helps improve overall efficiency. For example, the 3-lead device datasheet specifies the total switching losses of 226 microjoules, while the 4-lead datasheet device specifies only 80 microjoules for the exact same operating conditions. In short, the 4-lead improves the total switching losses by a factor of just under 3x. Either way, onsemi has you covered for world-class switch mode power supply performance. Now let's take a quick look at our USB-C power delivery reference designs for 65 watt and 100 watts. On the left, you can see an image of our 65 watt Type-C PD reference design with a 26.5 watts per cubic inch power density, supporting PD 3.0, programmable power supplies, and also BC 1.2. This uses an NCP 1345 quasi-resonant flyback along with an NCP 4306 secondary side rectifier controller and then an FUSB 15101 PD port controller. And this supports a full load of efficiency at full load of 93% and a standby power of 40 milliwatts. And then to the right, we've got the 100-watt reference design with a 24 watts per cubic inch power density supporting PD 3.0, including programmable power supplies and BC 1.2. And of course, this is over 75 watts, so we need a PFC. And for that, we've got the NCP 1623, along with the NCP 1345 quasi-resonant flyback and the secondary side controller, the NCP 4306, plus the FUSB 15101 PD controller. And that has a full load efficiency of greater than 92.3% with a standby power of 50 milliwatts. And now I'd like to share with you a block diagram of our 3 kilowatt power supply with a little bit more detail than before, and this includes silicon carbide. Okay, so this is a more detailed view of our 3 kilowatt power supply for applications that include energy infrastructure, energy storage, and lithium-ion charging up to 15S or 15 cells in series. For applications like robotics, industrial drives and pumps and power supplies. It includes PFC totem pole, LLC half bridge, and synchronous rectifier full bridge. And the peak efficiency is 94.2% at 115 volts and 96.5% at 230 volts. So looking down below from the left to right, you've got the AC input of 85 volts VAC to 264 volts VAC. On the far right, you've got your DC output, which is adjustable, either 48 volts, 62.5 amps, or 54 volts, 55.5 amps. Going back to the left, we've got our NCP 1681 total pole PFC controlling a slow leg and fast leg. For the slow leg, we've got silicon junction switches. For the fast leg, we use in silicon carbide. We're driving the silicon carbide with an isolated gate driver, in this case, the NCP 5156X or the NCD 5575XX family, 5 kV isolation. And for the silicon junction slow leg, we're just using the FAN 7191, a non-isolated gate drive. And so these two, slow leg and fast leg, perform the power factor correction. And then moving further to the right, you can see an LLC transformer with an integrated LR. And below that is the NCP 4390. That's our 2-for-1 combination secondary side controller and LLC controller. So you can see that feedback input goes to a resistor divider off the output on the far right. And that tells the NCP 4390 how to basically regulate the output. And it does that by driving both the secondary side and primary side. For the secondary side, in this case, we have a full bridge with 4 silicon junction MOSFETs driven by 2 NCP 81075 non-isolated gate drivers. And to the left, for driving the half bridge on the primary side using Elite SiC, we have the NCP 5156X or the NCD 575XX family of 5 kV isolated gate drivers. And so that, in a nutshell, is a summary of the 3 kilowatt power supply with a little bit more detail. And now let's take a look at our 7.2 kilowatt onboard charger block diagram, also using silicon carbide. Okay, so this 7.2 kilowatt onboard charger applications include EV charging for OBC or onboard charging level 1 or 2, or a power supply. The technologies include PFC 3-phase interleaved as well as an LLC full bridge. And the peak efficiency is 95.7% at 320 volts out and 95% at 400 volts out. And so on the far left, you've got your AC input 85 VAC to 264 VAC. On the far right, you've got your DC output of 250 volts to 450 volts with a 16 amp max. Moving back to the left, you can see the fan 90. Well, first of all, we have a diode bridge on the far left. And then following that, we have the fan 9673Q. That's our 3-phase interleaved PFC controller. It drives 3 different Elite SiC silicon MOSFETs, followed by 3 Elite SiC diodes. And we're using the NCV51705 gate driver. It's a 6 amp source and sink that includes negative bias. And we're also, so further to the right, we've got the NCV4390, that combination LLC and secondary side controller. So on the secondary side, it's controlling a full bridge, and on the far left, for the primary side, it's driving a full bridge, and we're making use of two 5 kV isolated SiC gate drivers, the NCV5156X. And then we're also using on the far bottom right an NCV210R, which is a current sense amplifier. So the processor in gray knows what the currents can do current sensing. And that's basically it. Thank you very much.
Thanks, Bob, for that great presentation. We already have several interesting questions, but I want to let our audience know that there's still time to submit your questions, again, using the Q&A tab. Okay, Bob, you ready to get started?
Sure. Sounds good. Thank you, Jeff.
First question, what improvements do you see with regard to EMC compliance?
Well, that's a pretty big subject, especially with the context of this presentation, where there's such a wide amount of power, going from tens of watts to like 3 kilowatt and a little bit above. But one of the things that most, if not all, of our controllers employ is a thing called spread spectrum. What that means is it'll have clocks, or I shouldn't say clocks. It'll have a high frequency signal that's driving these power switches, and so what we do is we jitter the frequency. So we're never always at the same edge rate in the frequency domain, and so by jittering the frequency plus or minus, you reduce some of that power and some of that EMI generation. So that's a very common technique in, I think, almost all, if not all, of our controllers. And then secondarily, there's filters you can employ throughout the power supply. It's a bit beyond the scope of this presentation, and to be quite candid, a little bit over my head. It gets quite complicated and very dependent on the application and the power levels and the topologies you're using.
Got it. Next question is about valley switching. How does the valley switching benefit from other switching topologies?
Well, the valley switching, typically we use that with a quasi-resonant flyback. And so the flyback is constantly turning on and off the power switch on the primary side. And so when it goes to do the next turn on, you'll have a lot of oscillations occurring due to the capacitance of that switch on the drain. So we seek we have algorithms built into our quasi-resonant flyback that seeks to find the valleys for the next turn on if it's oscillating. And that's very common as the loads get lighter, to switch in these valleys versus the troughs of the oscillations versus the high points, and that just saves on power. I'm not exactly sure what the question. I hope I answered the question, right? I think that's where the question's coming
from. Gotcha. Okay. What are the typical input voltages and output voltage of your switch mode power supply matrix?
Right. So for the input, we're typically 90 volts to 265 AC. But for the lower power up to 70 watts, we're typically 5 to 36 volts. From 70 watts to a kilowatt, roughly 12 to 24 volts. And then we bring it in a bit from 1 kilowatt to 3 kilowatt, 24 or 48 volts. Those are the common rails.
Okay. This is a question about SiC versus IGBT. Why don't you consider IGBT for the SPS over some power ranges, and how is silicon carbide superior to IGBT?
Right. You certainly can use IGBTs, and I'm a fan of IGBTs, and they're great products. But what you can typically do for the same amount of power, switching, you can typically switch faster with silicon carbide without introducing higher thermals. So if you did the same, the IGBTs have a certain F max, if you will, or maximum frequency for switching. You can go faster with the silicon carbide, And that again allows you, if you can switch faster, you can typically use a smaller form factor for the same amount of power, which is a benefit in many applications now, because you can typically use smaller capacitors, smaller bulk capacitors, input and output, smaller inductors, and smaller transformers. So that's usually the big benefit with silicon carbide.
Mm-hmm. Next question, what is the advantage of higher switching speeds of your controllers?
Well, like I just said, if you can use higher switching speeds, you can typically use smaller bulk capacitors, which take up a lot of space. Smaller bulk capacitors, transformers, and inductors. And so it saves space for the same amount of power. And many applications are driving smaller form factors or higher density.
Yeah, they want more in the same space, or they want smaller.
Yeah.
This is a very nice, very specific question. What is the feedback temp? Is the feedback temp compensated when using simple voltage driver feedback to the NCP 4390 in 3 kilowatt and 7.2 kilowatt designs? And what type of resistors are used in there?
Yeah, so I'd have to get back to you on that one. That's a good question. I don't know off the top of my head, but if you can, forward that to me by email, I'll get back to the asker of that question by email at a later time.
Yeah. Next question. Why don't you use slow leg switchers in 7.2 kilowatt technology, and why not full bridge front end rectifier?
Well, when we went to the 7.2 kilowatt topology, our total pole PFC kind of maxes out at about 3.5 kilowatt. We can't do it. We don't have an interleaved solution, meaning we can't put multiple power factor correction total pole PFCs in parallel. So we went to our other PFC controller that you can do interleaved, which allows us to go to higher power. However, that PFC is not a totem pole PFC. So we went back to the full bridge rectifier.
Excellent. Next question. How does the synchronous rectifier controller know when to turn on when there's no communication link between the primary side and the secondary side?
Yeah, that's a good one. So with that secondary side controller, in the old days, before you had a secondary side controller, you just had a freewheeling diode in the secondary side, and that would just naturally conduct when the primary side flyback turned off. And so what we do is we have a secondary side controller with a synchronous MOSFET in the secondary side, and that controller is monitoring basically the body diode or the current flowing through that device. And right away, when for a flyback, when the primary side turns off, then the secondary side starts conducting due to Lenz's law. That controller senses current flowing through the body diode, and then immediately turns that MOSFET on. And so the RDS on of a fully enhanced MOSFET dissipates a lot less power than a freewheeling diode.
Excellent. Next question. Do you introduce liquid cooling technology to make the form factor smaller like other domains?
Well, yes. That's certainly a reasonable thing to do. I personally have never worked with that, but I've seen it. And I'm not particularly experienced with that, but I understand that that's something, that you can do and works well.
Okay. Next question is, why is a power factor correction controller needed?
Well, when you get to roughly about 75 watts, the voltage and current can get out of phase, especially with different loads. And when that happens, you deliver less power to the load. That's one negative. But the other negative is you can send harmonics up the line and disturb other devices on the line. So I'm old enough to remember when I was a little kid watching Saturday morning cartoons. Yeah. If my grandmother ran the vacuum cleaner, my cartoons would get all snowy. And so that older, as my grandmother used to call it, the electric vacuum, the electric broom, that's what you call it. But anyway, that didn't have a PFC controller on it, so it introduced harmonics onto everything else tied into the house.
Excellent. Next question. What are the solutions for server power supplies like voltage, high current, like a high current application, low voltage, high current application?
Yeah, well, that's a big thing. Is the server power supplies really have to deliver a lot of power. It's all about the load, right? So when you look at these big FPGAs or ASICs that are in the servers, they have a 1 volt rail looking for 80 amps or something like that. So there's a lot of burden putting on the power supply to deliver a clean signal. And typically, that's a 12 volt output or a 48 volt output with a lot of power behind it. So that's really what I think that's what's driving it is, it's just driving a lot of current.
Got it. Next question. How does a total pole power factor correction PFC controller differ from a regular PFC controller?
A regular PFC controller is essentially a boost. So it boosts the signal and aligns the voltage and current, which a total pole PFC does as well, except for your traditional PFC has a full wave rectifier in front of it. The totem pole PFC, you can jettison the full wave rectifier and then use a slow leg and fast leg to do both. Basically do the boost and do the rectification. The bottom line is the traditional PFC with a full wave rectifier, there's always 3 devices in the conduction path. With a totem pole PFC, there's only 2 devices in the conduction path. So by dint of that, 2 devices in the conduction path is always going to be better than 3.
Got it. Next question: What solution do you have to restrict the high inrush current from solar panels type of applications?
Well, usually with solar panels, you have a different topology. You don't really have a switch mode power supply feeding off a solar panel. You typically have what's called, it's a boost. It's typically an MPPT, a boost with MPPT, which I can't remember what that stands for, but it's finding that sweet spot for power transfer from the solar panel. And you typically boost that into an inverter. And then that inverter is basically an H-bridge, which then, basically does pulse width modulation and generates that sine wave for the AC grid.
Got it. My camera looks frozen for mine. I'm just going to turn my camera off because it doesn't matter. Next question. Do you have certified solutions for electric vehicles, specifically ASL certified ISO 26262?
Well, we do ISOs. We have many products that are 26262 certified, ASIL B, ASIL D. Many of our individual components are certified for that would be in these topologies. So when you talk automotive, for like a switch mode power supply, that would be like an onboard charger, which, definitely many of our devices are gate drivers, our switches, not so much our controllers, but I'd have to double check on that if some of our controllers are ASIL.
Right, yeah. Next question. What is an efficient way to quickly identify EMC issues on power supplies in a pre-compliance test?
I'm really not that fluent with EMI compliance testing, EMC compliance testing.
Kind of a specialty, isn't it? Yeah.
Yeah, I just haven't done it. But I would imagine, I don't know what the person means by efficient ways, but to do it right, I'll bet you have to build a chamber and do it inside of a chamber because you want to exclude everything else and just, narrow in on the, what's the word? The aggressor, right? So it's all about aggressors and victims with EMC. Right. So.
Yeah, this is kind of a specialty. Another question, what's the safety shutdown options implemented in high power applications? Can you use functional safety domains?
Well, functional safety is a pretty big topic for automotive. I think that's what the person means for the question. And I'm not really sure I'm really skilled enough to answer that properly. Having sat in rooms with people who do know a lot about functional safety,
right?
I would say I'm probably not the right person to discuss.
Yeah, and there's like this automotive and there's aircraft. There's all different levels. Yeah.
Yeah, right. It's quite the there's quite a lot to it.
Well, Bob, it looks like we answered all audience questions. So I want to thank you, Bob, again for an excellent presentation, and thank you for sticking around for the Q&A.
Well, my pleasure.
Before we wrap up, I'd like to announce our prize winner for this session. So congratulations to Mohammed Z, that's Z-E-I-D, and Wayne Eckerson. We are going to be in touch with you within the next week to ensure that you have all the information you need to get the giveaway package. So thank you for attending Industry Tech Days 2024. And I want to thank our giveaway sponsor, which is DigiKey. And also I want to thank our events sponsor, which is Electronica. So if any of you happen to be in Germany the week of November 12th or 15th, I'll be there as well. But that is our event sponsor, Electronica in Munich. And so in a moment, you're going to be redirected to onsemi's exhibitor booth. And I encourage all of you to check out today's other live sessions, keynotes, and published content. Thank you again, Bob, and thank you to our audience.
Thank you, everybody. Have a great day.
EE Tech and Acuris kind of started to partner with each other in the beginning of the year and to kind of leverage each other's strengths. So Acuris is formerly known as IHS, is an electrical component data. That's what they sell. They've got 1.1 billion or more part numbers. They have compliance data, risk data, FMD crosses, etc. And at EE Tech, in our data team, we have a product called VDI, Vital Data Intelligence, and that is just a software product that delivers reports, alerts, and analytics. We have software developers that help out with that. And the kind of first joint partnership deliverable is Compliance Insights, which we launched, and I'm excited to share what that is with everyone, and I'll go ahead and demonstrate it as well. So if you're unfamiliar with REACH or PFAS, it's kind of a growing hot topic. PFAS are substances that are also called like the forever chemicals. They are basically plastics that are resistant to the, environmental degradation, meaning, they don't just go away in the environment naturally. They kind of last and stick around for quite some time. And REACH is a European law working to ensure a high level of protection of human health and the environment against harmful substances. So there's this growing expectation that these PFAS substances will be added on a whole scale to the REACH restriction substance list soon, and further regulated. There's maybe 10,000 different PFAS substances. And a very small subset of that is found in or common in electrical components. So here's just some articles that are kind of, validating and reiterating that that growing pressure. And so, for example, like the EPA is requiring that, reports of data and usage volumes of PFAS substances date back to 2011. Also, the European Chemical Agency has published a proposal that will ban and severely restrict, the manufacture, use, and marketing of thousands of proudly used man-made PFAS chemicals. And so PFAS isn't quite yet on the REACH restricted list, but it is moving in that direction. So the question that we ask ourselves is, what is your exposure to PFAS substances in your bill of materials and your products? how much of that exists, and how much are you at risk? And this is where Compliance Insights can come in and help answer that question. So what is the Compliance Insights tool? It's an online tool that enables electronics manufacturers to immediately understand how new or proposed legislations may affect their components. And it's pretty simple. It's upload your part list, your bill of materials, your products, and then upload a substance list of interest, in this case, PFAS. PFAS substances with a CAS number, and a CAS number is that unique identifier of that substance. And then, Compliance Insights has an interactive report, that will provide an analysis of part number, substance overlap, substance weight, etc. So I'm just going to jump into a quick demonstration of this before moving any further. And so I'm going to jump you into VDI and the Compliance Insight report. So this is VDI. And we have our Compliance Insights is right here. So the way that Compliance Insights is organized is we have the part list, the BOMs on the left-hand side in this area, and then we've got the substance lists on the right-hand side as well. So we'll start off by selecting a bill of materials, one that I've already uploaded. It's just a list of parts, kind of random. So this is the list. There's 107 parts with FMD data, or the full material disclosure data. We show 32 different substances in just this one part, or sometimes there's 24, or sometimes there's 6. And if you click on that particular part, we'll show you how that breaks down, what those substances are based on CAS number, and also the substance weight. We also have a substance view of your BOM. And so this orders it by the most, if we were to take all the components and just break them down into the substances, there's 241 different substances in that bill of materials. Silica being the most present with, 10,221 milligrams. And diiron trioxide and copper. We have like a visual representation of that here. And a lot of this makes sense. These are conductive type materials. And then if we go to the substance list, this is where you can upload a list of interest. In this case, I have preloaded a PFAS list, and I'll show you what that PFAS list looks like. If this is the example PFAS list, it's just CAS number, optional symbol and description. I've got here, these are actual PFAS ones, and they're, let's say, maybe 30 or so. So that list is this PFAS list right here. Okay. And let's go ahead and delete this. All right. And if I click this, we have that same list here with CAS number again and description. And this is kind of viewed as a Venn diagram. So we've got the list of 33 substances on the right, and we have the part list here with 107 components with FMD data. And then this overlap shows, where is there kind of overlap with a substance on the list and a substance in your bill of materials. And in this case, we do have an example where there's an overlap. So we can click on that. And of the 33, there is a substance called C2F4, or a PFAS substance. And it exists in one of the parts from the bill of materials. So we can click on this CAS number to find out more about which parts contain that substance, and it looks like there's this NIC part. And if we click on that, we get a breakdown of the FMD data, and we see that in the fluorocarbon polymer paste, C2F4 exists. And there's the CAS number, and there's 1.74 milligrams of that substance. So we know that our bill of materials does have PFAS in it. And, at this point, you can, you can take that part and look for a replacement. Maybe a cross and look at the cross and the available crosses and upload them in here and see if there's any PFAS in that, and make the right design changes needed so that you remove that dependency. So one thing that I do want to mention is this tool has flexibility beyond PFAS, and there's a lot more value that is that exists. And the reason and how do we get that flexibility, and it's the fact that Compliance Insights is not substance. It is substance agnostic. We don't really care. Like PFAS is just one of many substances that we can use. And that you can load. So for example, if you're interested in gold or titanium, or maybe there's a substance that's pertinent to your business, you can easily find out how much of that one substance exists in your products. And the reason why we're able to do that is because we're looking at the FMD data level. We're not looking at a parameter like REACH or RoHS. We're not leaning on those things. We're actually looking at the source of truth from the manufacturer. So why is it important to be fast? So we are fast, right? Compliance Insights performs this analysis and aggregation in real time. If you were to rely on REACH or SVHC attributes, it could take months or longer, to get that data updated, and that's after they're put on the REACH restricted list. We kind of go outside of that, and we don't really follow that as much. We just go again down to the FMD data, and it's important because the earlier you know that there is a problem, the more time you have to solve it. And as my colleague Scott says, it's pretty simple. Just load up a chemical list and go. So I want to show an example of this flexibility and speed. So if we go to the next slide here, this has been in the news recently. Antimony has export restrictions. So China is the leading producer of antimony globally. They provide 48% of all global production of antimony, and they are stopping the export of it. Antimony is a key material for like armor piercing ammunition, night vision goggles, infrared sensors, precision optics, electronics, right? And the United States has a dependency on this. We rely 63% of our antimony imports comes from China, and we haven't mined any antimony since 2001. Now, this export restriction went into effect September 15th, 2024, which is pretty recent, just a week or two ago. So how can Compliance Insights help with this potential problem? And the answer is we can actually you can use the tool to help you find what is your exposure to antimony. And we'll just go through that exercise real quick. So let's bring back the Compliance Insight report. Now since antimony is a new substance, we need to create a new substance list that includes it. And I'm just going to take, let's grab the cast number of antimony, and let's grab our list here. Okay, here's our list, and antimony is 7440-36-0. Antimony. And then let's just save this file. Save. Great. So we have that saved. And then in this upload, let's just call this PFAS with antimony. We can upload this from our device. We're just going to upload this PFAS example list here. Open. Submit and save. And here is the here's that list, and let's go ahead and validate that we have antimony in it. And we do. It's right here. Okay. So we can go back to our Compliance Insights report, and we can pull up our Compliance Insights demo with the parts, and then we can also pull, now we see that we have PFAS with antimony here. So we can select that substance list. Okay, and there's an overlap by 2 substances, which makes sense because we had the PFAS substance before that we found in that one part, and that hasn't changed. But we also have antimony present in our list of 107 parts, and there are actually 9 parts that contain antimony. So if we click on this cast number, we can find out what are the 9 parts. All right, and it looks like there's some NXP parts here with antimony, and let's go ahead and just pick one, and let's go through the validation process, right? So we want to validate, well, is this actually happening? Is it not happening? And do we really have it or not? So in the post-plating part of the component, it says we have antimony, which we do. So what I want to do is I want to validate this from the manufacturer. We have a section below that pulls, all the supporting documentation, and we have a full material disclosure document. So let's go ahead and open that guy up. This is from NXP for the 208K. And let's see if that shows up. And it does. So we have antimony in the post-plating lead-free. There's 0.0009 milligrams of it present. And that's what we're representing here as well. And yeah, so let me go back to the slides. So very quickly, you can just see how, we can discover our exposure to any products that you have, electronics that for a substance, any substance with a CAS number. And instead of, if we think about it, if you have lots of products and each of the products has, maybe 100 to 300 electrical components, and each of those components has maybe, 20 or 30 different substances. That's a lot of substances to go through, a lot of, a lot of manual effort. And if you have a list of 40 PFAS substances or anything that, or larger, and you're trying to figure out where do these things intersect and cross, and, and you're trying to do this manually by hand, it can be very, very time consuming. So that's where this tool can save a lot of time, and also bring out maybe some awareness to issues that you may not have already done a lot of effort in trying to expose. So that concludes the demonstration. If you have any, if you want to get in touch with me for any comments or questions later, I'll stick around and answer those. But you can also reach out to me directly. This is my email. I'm just tim@eetech.com. Happy to follow up with anyone who participated in the call. And again, I really appreciate you spending the time to just hear about compliance insights. Thank you very much.
All right. Well, thanks, Tim, for that interesting presentation and demo. We already have a pretty full question queue, but I want to let the audience know there's still time to submit your questions. Tim, Scott, are you guys ready to answer some of these questions?
Let's go. Oh, Scott might be muted.
All right.
Okay. I'm all set now.
Awesome. All right. Our first one is asking, how are REACH or PFAS different from RoHS compliance, and do any of these happen to be a superset of the other?
Yeah, I can jump on that one, Tim, if you like.
Sure.
Yeah, there's really a lot of different regulations out there, and what makes it so difficult is they're typically not subsets of one another. They typically intersect at some point, and sometimes in odd ways. In just kind of a brief history of them, I would say that RoHS, it was the first one to come out probably 15, 16 years ago now, a restriction on hazardous substances. And it's very much a vertical regulation. It's a European regulation that's transposed into each country's legal structure. But this specifically targets electronics, electrical and electronic type of products. So it's very product focused, and as of today focuses on 10 classes of hazardous substances, but it has a bunch of exemptions built into it that typically expire over time. REACH came several years after that, and it's a much more horizontal regulation in the sense that it applies to, it's very, very broad. So it applies to a lot of products, but it also applies to the registration process, evaluation in other processes for chemicals. But we typically talk about it in terms of reporting requirements and restriction requirements of the materials you can use in your electronic products. I would say, briefly, we break it down. We typically look at 3 different sets of substances. The list of substances of very high concern, SVHCs. These are about 240 some odd chemicals on the list now, and they have reporting requirements. So you have to, if you're providing this product down the supply chain, you have to indicate which of those SVHC substances are there, and actually new regulations actually requiring you in Europe to register those on the SCIP database. So a lot of stuff going on there. The second list associated with REACH is the authorization list. So things that have been on the SVHC list, the candidate list, are candidates for authorization, have been evaluated and put on the authorization list, which means you, based on various thresholds, but you need to go to the European Chemical Association to get approval, to get authorization to use those substances. Once substances are on the authorization list, they are on track to become a restricted substance where they're actually banned. You can no longer use them. It turns out there's a little bit of overlap between all of these at the individual substance level, but just because of the applicability of the regulations, Ross versus REACH, and exemptions used, these things really need to be handled individually. A good question.
Yeah, okay, thank you. And a great, and a lot of detail in that answer, and it shows how complex this is. Next question is, how often do you update your databases as new parts get released very often. And how do you keep track of all this?
Yeah, so our Acura's parts database is about 1.2 billion electronic components today. Most of the information and the parts that are in our database are entered into the database because we track certain types of parts, it's basically board level electronic parts, and we know the manufacturers that manufacture those types of parts. So we either get direct feeds from those manufacturers who want to make sure that their parts are visible in our database, or we monitor their websites for new parts that go out or for updates to existing parts. So it's a continual basis, basically triggered when we recognize a new part has been added by the manufacturer. We source that information, put it in the queue to add it to our database, which is a bit involved. We categorize each part, so we group similar parts together in a hierarchical finding structure, and then we define those similar parts in a standard way so you can compare parts even if they're from different manufacturers, or you can look for alternate parts. So that's on the database side of it. We're providing the material content to the EE Tech solution, so the FMD type information.
And next question, you kind of hinted at this answer a little bit, I think, Scott, in your first answer is, but what are some of the biggest or newest regulations that you're seeing out there?
Yeah, it's tough to keep track sometimes because there's so many. Yeah, so like we started, I'd say Ross was the first big one. There's been other ones out there, but Europe's kind of been consolidating over the last 20 years or so. So they have ROHS, they have the REACH regulations. They have other regulations in Europe, such as the POPs regulation, the persistent organic pollutants regulation. Here in the U.S., we have had California Prop 65, which requires you to mark. I'm sure many of you have seen. This product contains Prop 65 substances, and some details on that on some of the products you may buy. Other ones, I guess the other one, and Tim mentioned this one in his demonstration, and it's getting an awful lot of attention, is PFAS. So PFAS isn't a regulation in itself. It's really a group of synthetic chemicals. There's estimated to be, I don't know, over 12,000 individual chemical substances in this PFAS family. As Tim pointed out, the EPA through TSCA has various reporting requirements. They actually have a very interesting one in terms of the requiring companies in the U.S. or who make or sell products in the U.S. to do an 11-year look back to estimate the amount of PFAS they've used in their products. So it's really caught a lot of people by surprise, and obviously tools like the one that Tim just showed would really help there. PFAS is also becoming more prevalent in the European Union. There's a couple of the PFAS that actually are in, the REACH regulations sprinkled through it, but the proposal out there now is to take all the PFAS and directly add them to the restricted substance list. So we would expect to see that probably in the next couple, 2 to 3 years, I would say. And that would be an outright ban on using those in your product. So pretty critical to understand if you have those in your product. And sorry for the long answer, but I'll just say one more thing on that. So, we've been talking mostly about chemical regulations here, but as we work with EE Tech, and they showed us what they were developing with their tool. a lot of other use models popped up as well. So there's a lot of companies are concerned about chemical scarcity or material scarcity, rare earths, occurrence of rare earths, or the European Union has a list of critical raw materials that they want reported on. So a lot of companies are tracking those things, as well as like Tim mentioned about the antimony, these things that sometimes are concentrated in only a couple areas of the world. So if the political climate changes in such a way that you no longer have access to those, many of that may impact some of the parts that you're trying to procure. So that's probably a longer answer than you wanted, but some of the things that we saw and we're seeing with the regulations.
All right. Since we have a really long list of questions here, I'm going to kind of pick some that jump out at me. One of these here is we've got a lot of designers in our audience. Do you support any EDA design tools with your component database or compliance insights?
Yeah, I can answer that question. Yeah, no, so like EDA tools, OrCAD or Eagle or whatever you're using to design your PCBs. Currently, we're not directly integrated to any of those software tools. It could be something that if there's enough need for it, we can certainly direct our product roadmap in that direction. But at the moment, it's primarily to get this compliance insights. You'll need to download your bill of materials into a CSV file.
Okay. Speaking of looking ahead, this question is asking, can you share any features that you are working on for future product revisions?
Sure. So one of the things that we're working on right now, which probably won't take too long for us to really roll out, is creating a library of substance lists. So instead of just having one or relying on users to kind of upload their own, we could create kind of like a default collection of various lists. Maybe it's a RoHS or a REACH or a Prop 65 or an antimony or rare earth from EU, and just have a library list that is there, and we can keep it up to date and just allow users to not really required to know the CAS numbers or anything, and just make it, just, I guess, demonstrate the value, as well as we'll still offer the flexibility for customers to upload their own substance lists. That won't change, but just maybe make it a little bit more quicker and a better user experience. And the other thing that we're discussing is that we have on the roadmap as well is to create a bomb of bombs, is what we're calling it. Or just right now, the analysis is you upload a bill of materials, and then you can compare it with substance lists, but expanding just one bill of materials to like multiple and at the same time. And so, you could have like product portfolios, maybe in folders, and then, you have your substance lists, and you can apply more than one substance list. So maybe you want to check all your products at once against, multiple things like PFAS and antimony and REACH and RoHS all at the same time, and creating a kind of like a super list or a super report.
Yeah, and Tim, just to add to that, this is something that as we talk to clients, we get feedback on this particular feature quite a bit. Customers will come to us and they'll say, hey, we just heard, or actually management just heard about PFAS, and their general counsel came to their president, and the president came to me and said, hey, do we have to worry about this PFAS? What is the impacts of these PFAS regulations on our products? So by looking across all those bombs, your entire portfolio in one fell swoop, you can report on where those PFAS affect specific products and to what extent. So I think it's a really important capability that that the application has.
Okay, you definitely want to get ahead of those. We don't want general counsel involved, right? Next question is asking, do you also provide end of life and alternate supplier analysis?
Yeah, I'm sorry, you broke up on that a little bit.
Oh, sure. It says, do you also provide end of life and alternate supplier analysis?
Mm-hmm. Yeah, so this is today we provide a lot of information to EE Tech, and this is something that we've actually talked about. If you find something with PFAS, it'd be nice to find an alternate part without PFAS. So we've had those discussions. That's some of the content that we have in our Accurus database. So I expect we'll likely have some more conversations and talk about including things like that in the future. But I don't think there's any specific plans today.
Okay. And I think this next one's sort of related to that because do you also provide cross references for parts with PFAS?
Mm-hmm. Yeah, it's exactly the same. So alternate parts or cross references, the same type of situation for sure.
Yeah, it's definitely within the capability of our developers to produce that feature. And if you don't, we can look up crosses with Accurus' database. We've done it already, just not in this specific report. And we would scan the FMD data from those crosses and filter out the ones that continue to have substance violations or harmful substances, and just propose alternates, whether it's a form, fit, and function cross or a functional cross. We'll communicate that out. It's definitely within our wheelhouse and our capability. I think it's just a matter of time of when that feature gets added.
Excellent. How could you use this with an ISO 14001 system?
So stretching my knowledge here on this, I think that's the environmental management system, if I recall. I would say that provides the framework for managing environmental compliance, and so this could fit as part of one of the elements of such a system by actually tracking the information at the full material disclosure level. So for making sure that, as Tim described, making sure that you don't have restricted substances, identifying parts with them, if there's an issue, finding a way around that, either with another supplier or redesign or another part. Those are all components of that management system. So I would say that we provide the content for the parts that go into that, in the software that does this analysis would be part of a system that could be used for the 14,001. I don't know, Tim, if you had something to add to that.
No.
Yeah.
All right. Hopefully this one will be an easier one than that one. Is Compliance Insights a standalone product, or do I need to also purchase a license from IHS?
I can answer the easy ones. It is a standalone product, and you don't need to have purchased an Accurus license separately. Keep in mind though that it is specific to you're only getting access to Accurus's compliance data and their FMD data. Accurus offers a substantial, a lot more variety data and a lot more data than just that, including like cross references, part status, risk, parametric data and things like that. So all that type of data is not accessible through Compliance Insight at this time.
Okay. Is there a maximum number of substance lists I can use?
No, we actually don't limit the user on the number of substances per list or the number of substance lists that you want to upload. The limitation is more on the parts in the bill of materials, the part lists. So you can have as many part lists as you want, but in terms of distinct part numbers that you upload, that's where the limits come from. But most substance lists are as many as you wish.
And Tim, if I can just jump on to that one of the things that we hear from a lot of the clients that we talk with is they really like this idea of having a flexible chemical list that customers can describe themselves. So, clearly there's all the PFAS lists and the ROS and the REACH things, but they tell us that they have some of their clients want specific reports on their specific chemical list, and this just provides the ideal way to support those clients to do that analysis and provide them the content that they need.
That makes sense. Are there cases where part numbers don't have FMD data? And if so, what can you do?
Mm-hmm. And it's kind of a fact of life, unfortunately, that not all manufacturers provide this information. The information in our parts database is based on information that manufacturers provide. Over the 15 or 20 years since the restrictions on hazardous substances have been proposed and passed and are being enforced today, the number of manufacturers that are able to provide FMD and do provide FMD has grown considerably, but not everybody will provide FMD, and some of the FMDs still have areas that they would consider proprietary and not report on. But for the manufacturers that don't proactively report that, you can often collect this yourself. Just go to the manufacturer and request it. If you have more than a few parts, Accurus actually provides a service to do a project to go out and collect these. So we're typically dealing with projects ranging in size from a few thousand parts to a few 100,000 parts, where we would actually contact the manufacturer on your behalf and then provide this content. So I guess that's I guess that's what I would say.
Okay. Can the data and the reports be downloaded?
Yes. So any of the tables, whether it's the part list tables, whether it's the you select a part and go into look at the FMD data, those are all downloadable. The kind of the overlap tables, the substance list. So any of the tables that you view in the Compliance Insight report are downloadable. So you can download that content information and pass it on to the right person, or upload it into a system of your own.
Okay. Are you certified by any international regulation bodies?
Yeah, Scott, is this something you can?
Yeah, so I guess what I would say to that, and I gotta perhaps read a little bit into the question, so I hope I'm answering this. So, we provide an ISO 9000 process when we source and process the content in our database. So we do it at that level, but oftentimes our clients are more concerned about their specific processes and certifications for their actual products that they make. For example, people that are selling their products in Europe, they want to get the CE a marking, or be able to label their products with a CE mark. And to do so, they need to make sure that their parts are, for example, one requirement would be to make sure that they're ROS compliant to the latest version of ROHS. So using our content, with a tool such as the one provided by EE Tech, you can do that. So I think we help our clients in their certification efforts for their products, and Compliance Insight could be a critical piece of that.
Okay. This question is asking about whether you provide assistance on bomb scrubbing.
Yeah, I think I know on the EE Tech side, there are some services that we could do, but I would also first go to Accurus and see, because I'm pretty confident, right? Scott, you guys do professional services, scrub some bombs as well.
Mm-hmm. Yeah, exactly right. We can, and it's one of the things we talk about as providing a lot of value. The more parts you can match automatically, the more value you get from the system. So we can definitely help out in those areas.
Okay. Do you keep a log of the bill of materials that are provided so somebody could refer to that and then pull it later for a revised, change to that bill of materials?
Yep. So the quick answer is yes, we do. When you sign up for Compliance Insights, it's within our VDI platform or Vital Data Intelligence platform, and we basically have a part. We have a list of part lists, if you will, and that is accessible by anyone within the company of your company. So everyone can add their lists, and they can see each other's lists within the company, and you can go in and edit them if you need to add or remove parts, and you can delete part lists as well. So we don't we do give them the flexibility to come back later and either add a few parts or delete the whole list, or and we don't touch them. Well, we just let the customers organize it how they prefer.
We got a group here. I'm going to group these. They're all asking about different types of compliance. So they've got a question about EMI, then carbon neutrality, and then corrosion. So let's try to group those if we can.
Okay. Yeah, and that's a big area for sure. So I assume EMI is an electromagnetic interference thing. So on the Acura side, no, we don't cover that. Well, I'm sorry, what was the second one?
Carbon neutrality, net zero.
Yeah. Okay, yeah. I would say carbon neutrality is one of the biggest and quickest evolving topics out there. Our colleagues in Europe and customers in Europe are very concerned about this, as they're trying to be, carbon neutral. They are concerned about something called CBAM, Carbon Border Adjustment Mechanism, which basically, if you will, puts a tax on company or country, parts that have been made in other countries that don't have as strict of environmental regulations as there are in Europe. So people truly want to understand the carbon footprint, and usually when people, and this is an evolving area, but usually what people mean when they say the carbon footprint of an electronic component, they're talking about from cradle to gate. So everything it takes in terms of CO2 equivalent, so greenhouse gas, but reported in terms of CO2 equivalents, from the time that the metals were mined out of the ground and processed, and eventually, along with the other chemical substances used to make, for example, an electronic circuit. So from the time that pulled stuff out of the earth until you actually made the product and put it on your shipping dock, what is the carbon footprint? This is an area where many evolving standards out there and approaches to this. Most of these ultimately come down to estimations, various calculations. Obviously, it depends on where in the world these things are made. So things that are made where there's not as strict regulations will have a larger, assuming everything else is the same, they'll have a larger carbon footprint. So there's some tools out there, and I would say that they're evolving now. We're actually talking with some of our clients that are trying to model this with a hybrid system using some existing databases out there, but also using FMD, interestingly enough, to help them with their calculations. So today we don't have that. I would say that's a very active area of development.
Okay. And the third one on that list was corrosives, which
No. It's an easy answer. No.
But you could probably make your own corrosive lists and import it, right, and use that.
Yeah.
Couple more here before we hit to the top of the hour. Do you provide any information? This is interesting, kind of looking at the different direction. Do you provide information on the production houses? So you guys we've talked about components, but what about it going into the assembly process and the PCB assemblers of who is compliant there?
Mm-hmm. Yeah. So if it's in terms of compliance that is represented in the full material disclosure, obviously that would be a part of compliance insights. You could see that. If you're talking about other things with the deep supply, if you will, where semiconductor devices are actually manufactured, that's not part of the Accurus and the EE Tech relationship at this time, but we do provide tools in that area from Accurus.
Okay, we'll take one more here. Do you also keep track of obsolete components? So guidance on that when the bill of materials may be something is becoming obsolete.
Yeah, we do. And I guess the first thing that I'll say is a lot of our clients in aerospace and defense or telecommunications or even medical devices, they traditionally have products that are long production or long product maintenance type products that can last for 5, 10, or get into military applications more than 50 years. So we do have, when we provide information or when Compliance Insights accesses information on parts for the FMD, it includes all the parts that are out there. So if we have the FMD, even if the part is obsolete, you'll have access to that and can use it in Compliance Insight to understand the material makeup of that. And I guess the other thing that I'll add to that is that quite often, even if the part is obsolete, it's available in the supply chain and actively used. So yeah, it's an important thing to be able to continue to support, and you'll see those parts in Compliance Insights.
Okay.
Yeah, and I'll just add that the part status is something that we do have access to and have used it for other purposes for different reports. So it's very simple for us to integrate that into Compliance Insights. We just haven't done that yet, but if there's a strong enough need or a strong enough desire, it would be very simple for us to make that possible.
Well, very good. Well, thanks, Tim and Scott, for the demonstration and then the really lively discussion. Appreciate it.
Yeah.
Thank you, everyone.
Yeah. Thanks, everybody.
Before we wrap up, I get to announce the prize winners for this session. Congratulations, Carlos Hidalgo and Path Ramirez. We'll be in touch with you within the next week to ensure we have the information we need to send you the giveaway package. And we'd like to thank our friends at DigiKey for sponsoring Industry Tech Days and this giveaway. And thank you to our event partner, Electronica. We hope you join All About Circuits and EE Tech Group in Munich from November 12th to 15th at Electronica's in-person trade show. In a moment, you'll be redirected to the Accurus exhibitor booth. Thank you for attending Industry Tech Days 2024. I encourage you to check out today's other live sessions, all the keynotes this week, and the published content.
All right, less than a minute, and then we're ready to go.
All right, I'll be ready. Hello, everyone. Thank you for joining us for Industry Tech Days 2024. I'm David Peterson, the Director of Engineering Content at Control.com, and I'll be your moderator for our next session, which is titled Powering AI from 48 Volts to Core. Let me tell you a little bit more about today's presenter. Christian Hofling boasts over 15 years of experience in the power management industry. For almost 4 years, he has been working as a field application engineer at Infineon Technologies. Prior to that, he held several technical positions at Intel, Altera, and Texas Instruments. With a strong background in high current, multi-phase DC to DC and point-to-lead solutions, targeting customer data center and high-end computing and AI applications, Christian helps customers architect and design next-generation AI-powered solutions, unlocking their full potential. Unfortunately, we won't be able to address any questions live during this session today, but we still encourage you to submit questions at any time during the session using the chat box that's over on the right-hand side of your screen, and those will promptly be answered by Christian and the Infineon team. There will also be a few helpful links provided at the conclusion of the presentation, so keep an eye out for those in the Handouts tab. Thank you so much for joining us today, and with that, I'll hand it off to Christian for the presentation.
Hello, my name is Christian Höfling. I'm a field application engineer with Infineon. Today, I want to talk with you about artificial intelligence, or short, AI. AI can make our lives so much easier in so many ways, whether it is on our daily commute by car to work as a driver assistance system in the car, or answering our prompts in ChatGPT. Today, I want to take with you a glance behind the brilliance of AI. What does it take? What is behind powering all those AI services? First, let's talk about what is AI. Artificial intelligence, or AI, is a technology that enables computers and machines to simulate the intelligence and problem-solving capabilities of a human being. Generative AI actually is a type of artificial intelligence technology that can produce various types of content, for example, text, images, audio, or synthetic data, where synthetic data is a set of data that is actually generated by an AI algorithm rather than real measurement data. Examples for AI use cases out of our everyday life is, for example, advanced driver assistance systems, as a collision avoiding assistant, as an emergency braking system, or even autopilot. Or in financial services, where business models can be modeled, revenue forecast can be modeled. In healthcare sector, for example, AI can analyze X-ray images or analyze a large set of patient data, or as a digital assistant or a chatbot. Already today, 77% of global population is using AI today. 92% of Fortune 500 companies are using AI technology. There's a forecast that by the year 2032, the general market for AI will be $1.3 trillion US. Artificial intelligence is definitely a technology that is here to stay. So let's have a look. What is the difference between AI-driven technologies and other online platforms or social media platforms in adoption rate? If you look here, how long did it take, for example, ChatGPT to reach 100 million active users in days, compared to social media platforms like Instagram, Facebook, or online services like Spotify or Uber? For Uber, for example, it took more than 2,000 days to reach 100 million active users. Instagram took a few hundred days. ChatGPT took 5 days to reach the 100 million active user threshold. This is definitely an adoption rate that is unbelievable. In order to cope with this pace of adoption rate of AI, it requires data centers to provide the computing power to service this request. If we look into the single processor electricity demand over time, over the years, we see a tremendous increase in the processing power demand driven by AI processors, AI GPUs or AI SoCs. Basically, this is driven by the amount of computing power that is required to train cutting-edge AI models. Actually, we see a doubling of the computing power every 3.5 months since 2012. So today, if we look into AI processor has a power demand today of up to 750 watt, and we see an exponential increase looking forward, coping with the demand of AI users. This leads to the point that power management cannot be an afterthought. If we look into an AI processor demand in a modern AI server by 2022, processor power was in the range of 400 watt, increased to 750 watt, and by the year 2026, we see the power demand per processor going in the range of 2000 watt and higher. So processor power is rapidly increasing, power demand is rapidly increasing. One hand side is really the computing power, on the other hand side is the power efficiency and how we use the power inside of the data centers. So really power management and making the power conversion, making the power management as efficient as possible cannot be an afterthought and needs to go hand in hand with the development of the AI processors. So if we look at the electricity consumption worldwide, already in the year 2022, we saw data centers consuming 2% of the global electricity consumption. There's models that predict that by 2030, which is basically around the corner, this electricity demand will rise in the range between 3.5% to 7% of the worldwide electricity consumption, growing at a tremendous CAGR of 15% from 2023 to 2030. What kind of societal challenges does this bring with it? One hand side, drain on the grid power. It's definitely a challenge for electricity grid, especially for large data center hubs like the United States, where we already see data center power demand growing up to 7% overall. Of course, it brings along as well environmental challenges. For example, the carbon footprint. Running AI servers is a very energy intensive process with a significant carbon footprint and CO2 emissions. Then up to 50% of the energy consumed in a data center is used for cooling. So this has definitely big water consumption in the data centers today. Last but not least, the electronic waste. AI servers contain hazardous materials and chemicals such as lead and cadmium that can contaminate our environment. Today, we have more than 10,000 data centers worldwide, 50% of them based in the US, 500 in Germany, 450 in China, as well as Ireland. This can mean a big challenge for the local grid in the country. For example, if we look at Ireland, by the year of 2026, 30% of the total electricity consumption could be in data centers, compared to 70% in the year 2022. Let's have a look at the carbon footprint of a data center. Electricity generation to power the data center is directly connected with emission of greenhouse gases. Fueled by generative AI and running AI servers, this becomes very energy intensive. About 330 million metric tons of CO2 is the amount emitted by data centers and data transmission networks in the year 2020. This is about 10% of the emission of the largest coal-fired power plant. Let's have a closer look inside the data center. In the data center, we have AI rack servers. What you see here is the potential implementation of an AI rack server. In the rack server, we have top-of-the-rack switches, which are high bandwidth switches that interconnect the servers inside of the data center. You can imagine this as like the data highway coming into the server and then getting distributed inside of the server. We have, of course, power supply units that power the inside of the server. Coming from the outside with AC, these power supply units convert the AC into DC voltage and then distribute it inside the server to power the individual blades in the server. Then there's a backup battery unit. In case of a mainline outage, the battery backup unit needs to cover and support the server with electricity until the auxiliary and emergency power supply, for example, a diesel generator, is up and live and supplying the data center and the server. Infineon, of course, has solutions and products for all of these applications. Top-of-the-rack switches, power supply units, as well as backup battery units. Let's have a little bit closer look at the AI-specific portion. Inside of this server, there are so-called AI box servers. In this example, there is overall 4 AI box servers. Let's have a look inside of the box server. In the box server, there is a motherboard which is running a host CPU. But this is the same setup as in a traditional server. Then there's network interconnection cards that interconnect the individual blades in the server, that interconnect the individual AI box servers with each other. And then we have the baseboard for the AI accelerator. This can be GPUs or AI-specific SoCs in different form factors, for example, PCIe cards or open accelerator module cards. Typically, power is distributed within the server through a bus bar. In modern server architectures, this is a 48-volt bus bar supplying, for example, the GPU cards or AI OEM cards. Inside of the baseboard here, we have up to 8 OEM cards, open accelerator module cards, that are actually the accelerator AI processor. Let's have a look into the power architecture inside a data center and inside an AI server. We come with grid power into the data center, into the server, and then there is the power supply units that convert the AC voltage into a DC voltage, which is then distributed via a bus bar in the server. In this case, 48 volt. Now you might say, hold on, I'm used to a 12 volt bus bar application in traditional servers. Why is this changing to 48 volt? Modern data centers more and more move over into 48 volt power distribution inside of the server. The reason for this is power efficiency, to reduce the power losses in the power distribution. Equation for power loss is I squared R. Going from a 12 volt intermediate bus to 48 volt actually cuts the current, the I, into 1/4. 1/4 of the current means 1/16 of the power loss in the power distribution. This brings another challenge with it. There is additional voltage conversion step required coming from the bus bar to the processor core supply, requiring an intermediate bus converter. Now let's have a little bit closer look into the intermediate bus converter. For the intermediate bus converter architecture, there's actually 2 options, a regulated converter or an unregulated converter. For most cases, for example, open accelerator module cards, unregulated architecture is fine because there's no component on the OEM card that actually requires a regulated 12 volt. There's post-regulation happening after the intermediate bus converter to, for example, the AI processor core voltage or I/O reels. So there's different options available in conversion ratios. For example, 2:1, 4:1, 5:1, 8:1. And there's a dedicated topologies that are either based on switched capacitor converters, so no inductive, no magnetic components required, or into hybrid components, or as well components that require magnetics. There is as well some applications that require 12-volt regulation, so really a regulated output voltage. Infineon has solutions in the portfolio for all of them. Let's look a little bit into the Infineon IP for intermediate bus converter topologies. For example, ZSC. ZSC is a zero voltage switched capacitor converter. As the name says, it's a switched capacitor converter. No inductors, no magnetic components are required. This topology suits best low profile requirements as a down solution, so as a discrete solution. It is a soft switching topology, so there's no hard stress for the switching components, for the FETs or noise. There's no transformer required. It is quite insensitive to variations on component level or input voltage level. We can support a peak power level of 200% of the converter's TDP, the thermal design point, which is the power level that the converter is designed to continuously operate. We can achieve conversion ratios. The best conversion ratios for this topology are 2:1 or 4:1. So input voltage is 2 times the output voltage, or input voltage is 4 times of the output voltage. If higher conversion ratios are required, we can switch to another topology, so-called HSC, hybrid switched capacitor topology. It's best in class in terms of power and efficiency for power levels up and above 2 kilowatt. It's available as a down solution, as a discrete solution, or module implementation, where the module implementation really suits best here. Same as the ZSC topology, it is a soft switching topology with low stress for the switching components for the FETs. As same as the ZSC, it is insensitive to variations on components and input voltage. We can implement here GaN technology to further reduce and shrink the footprint. As well, peak power levels of 200% and higher than thermal design power are achievable. Best ratios here are 5:1, 6:1, and 8:1. For applications that require regulation, we have DR-HSC topology in our portfolio. At the end is a two-stage topology of a 2:1 ZSC converter followed by a 3-level flying cap converter. This suits best discrete implementation. It's the best combination for power efficiency, footprint, and provides regulation. It's a dual-stage soft switching ZSC stage followed by a hard switching 3-level flying cap regulator. It decreases the voltage stress for the switching components. Peak power levels of up to 150% of the thermal design power can be achieved. Best conversion ratios are 4:1. So we're talking about 48 volt to regulated 12 volt. So now the big question is, what is the optimum intermediate bus voltage, or what is the best conversion ratio suiting your application? Let's have a look at this graph here. This is a two-stage power loss breakdown with the first stage intermediate bus converter followed by a second stage converter that takes the intermediate bus voltage and converts it into AI processor SoC core voltage. In that case, we're talking about 1 kilowatt intermediate bus converter and powering a CPU consuming 500 watt thermal design power. So what we compare here is a 4:1 conversion ratio, 5:1, 6:1, and 8:1 conversion ratio. The overall losses that are shown here are broken down into orange, second stage losses. So this is the power losses in the post-regulation, taking the intermediate bus voltage and converting it to the processor core supply voltage. PCB losses, which are the losses that happen in the copper of the PCB, so conduction losses by transporting the power from the intermediate bus converter to the point of load converter into the processor. And then first stage power losses, which is actually the losses that happen in the first conversion stage, so coming from 48 volt to the intermediate bus voltage. If you take a look at this graph, it's quite obvious that a conversion ratio of 4:1 or 5:1 is in favor of today's VR technology. Further power reduction can be achieved by moving to lower voltage second stage power conversion of voltage regulator components, going to 6:1 or 8:1 conversion ratio in combination with lower breakdown voltage power stages or lower breakdown voltage power modules can further reduce the power losses. Now let's have a closer look into the point of load coming from the intermediate bus to the processor core supply. What kind of requirements do we typically see here? Typically, we see a very high output current requirement for the voltage regulator. Up to 2000 amps peak current are not seldom. Then we typically operate with very low output voltages, supply voltages for the AI SoC, typically in the range of 0.6 volt up to 900 millivolt. We require very tight output voltage regulation, typically in the range of plus minus 3%. Remember, 3% of 700 millivolt is 21 millivolt, so requires very tight regulation. Due to the low supply voltage level and the tight Vout tolerances that are required, features like load line are typically not applicable for these applications. We are challenged with load transient. Load steps in the range of 1000 amps absolute load step are very typical. We see slew rates of this load step of 2000 amps per microsecond or higher in such applications. Most of the time, the AI system is running at full power all the time, 24/7. What challenges do these requirements imply? Typically for the high current demand, we require a very high phase count. 16 phases, 20, 24 phases, or up to 32 phases are typical in AI applications. High current efficiency power stages are required to cope with the power losses. We require packages and power stages in thermally enhanced packages. Better dynamic phase current balancing is required because we have a very high phase count with a very dynamic load, so we need to balance out the current in the phases. We require best-in-class low transients. We talked about low transients, very high low transients, up to 1000 amps with very fast slew rate. It's definitely a challenge on the PCB layout to transport and bring the high current from the VRM into the processor. Sometimes, due to limitation on the power source, there's multiple power sources required. For example, in PCIe cards, where we cannot draw all of the power through the edge connector, but need an auxiliary connector, for example. So we need to work with multiple input voltages. Due to the form factor, like PCIe or open accelerator form factor, these applications are very space limited. So what kind of products does Infineon have in the portfolio to address the second stage point of load high current application? We have multi-phase controllers up to 16 phases to address the high current demand. Then very efficient high current power stages with really advanced packaging technology that provide a very good thermal performance. Then we have power modules that are fully integrated modules that integrate up to 2 power stages with inductors, shrinking the solution footprint by up to 40% versus discrete implementation, while at the same time increasing the efficiency up to 2%. Then for lower current rails, we have integrated point of load regulators that address lower current, lower power rails on the board. As example, memory rails, I/O rails. Let's have a look at the voltage regulator solution for super high current applications. This requires, as said before, multi-phase controllers and power stages. So we have 8 phase controllers that are able to address up to 300 amp thermal design current. 12 phase controllers that are able to address up to 500 amp. 16 phase controllers where we are able to address up to 600 amp thermal design current. And by using dual PWM or dual mode, so one PWM pin driving 2 power stages, we're actually able to extend this range up to 1200 amps thermal design current. Infineon has best-in-class power stages that enable highest power density. What we have here is a chip-embedded packaging technology that helps to improve power density versus competition by 30%. At the same time, providing very high efficiency, outperforming the competition of like 1 to 1.5% in peak efficiency, and especially at high current applications, high current per phase, 2% or better efficiency versus our competition. Infineon provides best-in-class power density through vertical power delivery solutions, such as multi-phase power stage modules. Here we have a vertical integration of the power stage with the inductor. With this innovative packaging technology and Infineon's patented cool core magnetic, we are able to achieve very high power density while at the same time maintaining very high efficiency. If we compare the Infineon power module solution versus power module solutions available in the market, we see up to 2% better efficiency with the Infineon solution. This can provide up to 2% energy saving equivalent to $14 million US, annual total cost of ownership saving for a typical AI data center provider. Let's have a closer look into the Infineon power modules. We have different power modules available in our product portfolio. Already released products are the TDM22454, which is an 8mm product, and the TDM22455, which is a 5mm product. Both are in a pin-to-pin compatible 10 by 9mm footprint and are already fully released today. Both modules provide a peak current capability of 160 amps maximum and a thermal design current of 80 amps. There will become TLVR options of this module available, as well in a 10 by 9mm footprint, 8mm height and 5mm height. Those products will sample early in Q1 2025. In the next step, we even further increase the power density, shrinking the solution size of the module. The TDM23541 remains at 160 amps peak current capability while shrinking the footprint of the package to 8 by 8mm and as well shrinking the solution height to 4mm. Question is now, why choosing a power module over a discrete solution? Let's have a look here. Comparing the efficiency of the TDM22544 fully integrated power module versus the discrete implementation. We see especially at high current an advantage in efficiency of up to 2% of the power module. This is due to the optimization of the PDN. Let's have a look here on top. This is the power stage sitting side by side to the inductor. So we have lateral current flow through the PCB and therefore losses in the PCB, in the copper in the PCB, in the interconnection between the power stage and the inductor. Where here with Infineon's patented cool core technology, where actually the inductor is sitting on top of the power stage, we have vertical current flow through the inductor, out of the power stage, through the copper clip back to the PCB, which is really optimizing the power losses inside of the module. Key features of our TDM22545 product family are very high current density of 1 amp per square millimeter, peak current capability of 160 amps peak current, 80 amps continuous current or thermal design current, and a very small footprint, 10 by 9 by 8 or 5mm. We support a wide input voltage range of 4.25 up to 16 volt and can operate up to switching frequencies of up to 1.5 megahertz. The power stage provides a very accurate output current telemetry of plus minus 2%. And we have a very low thermal impedance junction to top of the package due to Infineon's patented cool core technology. The module provides a very low thermal impedance of the power stage junction to top of the package of roughly 3 degrees Celsius per watt. Our competitors are as well providing power stage modules in the same form factor, where all of our competitors actually place the power stage on top of the module. This has significant disadvantages. If you look at efficiency between competition modules, that have the power stage on top versus the Infineon module, we see an efficiency benefit of our module of up to 2%. Placing the power stage on top makes the overall module more mechanical fragile because it's exposed to top board flexure and can damage the components and interconnections. Overmolded power stages have a higher thermal impedance versus, for example, Infineon's chip-embedded packaging technology. Power stages on top means higher noise and signal noise and power through the connectors. There's vertical PCBs required or connectors required to interconnect the module substrate to the power stage that is sitting on top. We see a high resistance from input and ground paths, actually bringing the input voltage to the top of the module to the power stage, and as well interconnecting the ground into the PCB. The Infineon solution is mechanically more robust and can sustain more than 100 psi compression. Chip-embedded power stages in combination with direct copper connection and Infineon's cool core topology provide state-of-the-art thermal resistance. We have a direct solder connection of the power stage to the motherboard, and we have a single substrate that minimizes the overall resistance. The efficiency advantage of the Infineon power module in combination with the superior thermal performance yields to up to 5 degrees lower junction temperature at a given power level versus the competition. Let's have a look at an actual case study. In this case, there is an SoC, AI SoC, sitting on the top side of the board, and the power stages are actually placed bottom side underneath the SoC. So we have really a vertical power delivery architecture. In both cases, so we compare here Infineon's power stages with power stage sitting on bottom of the module versus competitor solution where the power stage is actually sitting on top of the module. In both cases, there's 26 dual phase modules used, which translates into overall 52 phases. There is a cold plate attached to the top side, to the processor of the board, as well a cold plate attached to the bottom side of the board, touching the surface of the modules, cooling the power modules on the bottom side. If you talk to the inductor cooled solution, which is the Infineon solution, we see a total power dissipation of 74 watt versus 95 watt. So this is 2% better efficiency of the Infineon solution versus competitor solution. This translates into a maximum PCB temperature difference of 5 degrees. So the Infineon powered solution can operate 5 degrees colder versus the competitor powered solution, 85 degrees versus 90 degrees. This translates into a junction temperature difference inside of the power module of 6 degrees, 90 degrees with the Infineon solution versus 96 degrees with the competitor solution. So this provides more headroom versus thermal shutdown. We can push a little bit more power or can operate at higher ambient temperatures or PCB temperatures. Let's have a look on how we can reduce the total cost of ownership with the PDN, so the power delivery network. First of all, let's have a look at a lateral power delivery network. In this case, we have the processor sitting side by side to the intermediate bus converter, which is the first stage conversion, 48 volt to intermediate bus voltage, and sitting next to the voltage regulator, second stage voltage regulator, which is converting the intermediate bus voltage into the core supply voltage for the ASIC. So what we see here, we basically occupy this space here and the top layers of the PCB with copper delivering power from the intermediate bus to the second stage converter and from the second stage converter to the ASIC. And we as well block the real estate in this case. We have copper losses in between the IBC and the second stage voltage regulator, and as well the second stage voltage regulator to the ASIC. Let's have a look at the vertical power delivery implementation. Vertical power delivery gets enabled by the voltage regulator module. At a very small solution size, we are actually able now to place the second stage VRM underneath the SoC. So basically we place it bottom side underneath the SoC. Now have vertical power flow through the PCB directly to the processor, thereby minimizing the losses in the PCB, minimizing the copper losses, and as well optimizing the parasitic loop for the supply voltage between the VRM and the processor. So we really minimize the parasitic, the inductive loop, and as well help to improve the low transient performance, help to reduce the amount of capacitors on the board. As I have shown you before, the advantage of a power module versus a discrete implementation where the power stage and inductor sit side by side to each other as well brings with it up to a 2% increase in efficiency, which translates into overall TCO benefits. Let's make the calculation here. Inside of the AI box server, there are AI cards. There's up to 76 watts of power saving per AI card. 8 AI card per AI box server translates into 654 watts in power savings per AI box server. There is 4 AI box servers in one server rack. Now, assuming electricity cost of $20 per kilowatt hour, this can translate in $1,728 saved per day of operation, translating into $630K saving per year. Let's have a look what's coming soon. Our next generation upcoming TDM23541 that we'll be sampling in fourth quarter this year will bring the solution size and power density to a new level. Up to 1.5 amp per square millimeter, 160 amps peak current, 80 amps continuous output current in an 8x8x4 millimeter footprint. Let's have a look at efficiency, like 600 kilohertz switching frequency, 12 volt input voltage, 0.8 volt output voltage. We talk about 90.5% peak efficiency, above 89% efficiency at full scale output current of 80 amps continuous. If we compare the next generation TDM23541 versus the previous generation, we see an increase in current density, 1.5 amp versus 1 amp per square millimeter, 35% smaller footprint, while at the same time improving the conversion efficiency by almost 0.5% compared to the 5mm TDM22545. You can see the efficiency difference between TDM23541, the 8x8mm module, versus the previous generation module in the graph here. We see up to 0.4% improvement in peak efficiency. What we see as well is a benefit in the thermal performance. While both modules, the new TDM23541 versus the TDM2254X, have almost the same thermal resistance junction to the top of the package, we were able to further reduce the thermal resistance junction to board by a factor of 3. We have thermal resistance junction to board of 0.5 degree per watt versus 1.8 degree per watt versus the previous generation. If we look at the solution size, for example, if we look on how many modules, how many phases we can fit within an area of 25 by 25 millimeters, we are able to fit 9 modules, which is 18 phases of the new module versus 4 modules, which is 8 phases of the previous generation 10 by 9 millimeter module, which equates to 125% increase in phase count within a 25 by 25 millimeter area. What did we learn today? AI is currently fueling a data center boom. Processor power and overall data center power is increasing at a very rapid pace. Therefore, efficiency in power conversion is really key to responsibly use our natural resources. Infineon has the right product portfolio to drive digitalization and decarbonization forward. Now we concluded the presentation. I'm looking forward for your questions in the Q&A section.
And our thanks to Christian for that great presentation. And we want to remind the audience once again that any questions that you did submit during the session today, those will be sent to the Infineon team to make sure that you can learn as much as possible from this session. And also be sure to check out those links that were provided in the handouts tab to learn more about the products that were presented in this session. And before we wrap up, I'd like to again announce our prize winners for this session. So congratulations to Dewan Sahu and Ngok Lee. And I would also like to announce our grand prize winner for today. Congratulations to Doug May. You've won today's grand prize courtesy of Mouser Electronics. We'll be in touch with all of our winners within the next week to ensure that we have the information we need to send you your prizes. And thank you to our audience for attending Industry Tech Days 2024. A special thanks to our event and giveaway sponsor, Mouser Electronics. And thank you to our event partner, Electronica. If you happen to be in Germany, November 12th through 15th, go check out their in-person trade show in Munich. In a moment, you'll be redirected to Infineon's exhibitor booth, and I encourage you to check out the other live sessions, keynotes, and published content for the remainder of our Industry Tech Days 2024. Thank you and have a great day.